Good morning to everyone. I hope my audio is clearly audible to you. Yes. Very good morning, all of you. So now, yesterday we have been discussed about different conditions of the CPAS. And today we are going to discuss about the remaining conditions. Let's start our today's session. So, if you observe, now, see, yesterday we discussed about these conditions of artesian height, artesian pressure, and all of these things. And we discussed about the quicksand condition. So the last topic we have discussed in yesterday's class is quicksand condition. And I told you what is meant by factor of safety also, resisting by causing, which is a downward pressure by upward pressure. So how to determine the factor of safety? What is a critical hydraulic gradient? And what happens if a surcharge is applied over here? So if a surcharge is applied, obviously factor of safety is going to be increases. And then I told you there's a quicksand condition occurs in what type of the soil masses. So, and these are some of the silent features of the quicksand condition. And you know that quicksand condition occurs on the downstream side with an upward CPAS when the upward pressure and downward pressure both are going to be same. And we discussed about the CPAS forces per unit volume. And we discussed about how to determine the CPAS means whatever the pressures or effective stresses at any section when there is a CPAS. I hope you people Mr. Sachin Alango, sir, how to speak with you at the doubt clearing session? I don't know how to do that, please. Mr. Sachin Alango, at the bottom of your page, whatever you are seeing at the bottom of your page, so where there is an option of given comment, next to that there is a hand symbol. There is a hand symbol. Right now I disabled that hand symbol. At the end of the class, I will enable that hand symbol. If you click on that hand symbol, that will give a notification to me that Sachin is able to talk with you. Then if I click on that, then you can speak with me. So at the end of the session, you please click on that hand symbol. Yeah, today I'll definitely tell you how to prepare for the examination and the preparation strategy. But let's start the class. And meanwhile, in between the class, I'll share that preparation strategy. So now let's come into the session. Yeah. Okay. So now I told you this quicksand condition will cause us failures to the soil. So what is that failure and how we are going to prevent that failure? What is that failure and how we are going to prevent that failure? So number one, piping failure. I hope most of the people have already heard about the piping failure. And for that, I will open a link also so that you can understand. So first, I'll discuss about this piping failure. Then I'll discuss about the video link. So now, in the case of the piping, what happens over here is again. Let's take this as a gravity dam. Upstream bed, downstream bed, upstream water level and downstream water level. So now you see this is upstream water level and this is a downstream water level, and here it is going to be a dam. This is upstream bed and here it is going to be the downstream bed. Now if you observe clearly, when there is a seepage on the downstream side, see this is the point where we are finding out. On this downstream side, the seepage will travel, to a distance of z, and whatever the head over here, let's say you have started with the difference between the total water difference. So the difference between the total water levels is a capital H. So you start with the H. Now, by the time you reach over here, you will lose a lot of head, and whatever the head remaining will be the seepage head at this point. So now, whatever the head, let's take the head H. So you know that the downward is going to be submerged gamma dash into Z, and upward is going to be gamma W into H. So everything we know it clearly. But now the question I'm asking you is, whenever the upward pressure and downward pressure both are same, then the quicksand condition or boiling condition will comes into the existence. Now, what happens if it goes beyond this? What happens if the upward pressure is going to be more than the downward pressure? So just simply observe, if the upward pressure is more than the downward pressure, and due to this pressure, you see, this is upward pressure, this is a downward pressure. I hope you can able to see this. Downward pressure is gamma dash into Z. Upward pressure is gamma W into H. When both are same, then the condition is critical condition and causes a quicksand condition. Now, when the upward pressure is more than the downward pressure, what happens? Due to this upward pressure, the entire soil mass will lift up R naught. You observe here, this is downward, this is upward. Due to this upward, entire soil will lift up. So now you see, due to this upward pressure, this entire soil mass will lift up. And when this entire soil mass is going to be lift up, now you see, when the entire soil mass is going to be lift up, you observe whatever the soil mass here, it will lift up, right? When it lift up, now this entire motion is going to be act on the downstream side or not? Yes. When the quicksand condition occurs, beyond that, on the downstream side, due to upward force, what happens over here is then whatever the soil, due to the kicking of this seepage pressure, this entire soil will start to lift up and causes an erosion. Sir, how does an erosion looks like, sir? Now you observe that erosion is going to be looks like on this top, this entire soil mass will starts to comes out. The entire soil mass will starts to comes out. This is known as a soil erosion. And once it starts on the downstream side, it won't stop. It starts on the downstream side and it moves towards the upstream side. See, whatever the soil mass in between, the soil mass is going to be gets eradicated, means eroded. Now this will move towards the upstream. When it moves towards the upstream, now you see this is nothing but the erosion of the soil or not. When the soil gets eroded, what happens? It is going to be create a larger space for the flow or not? Yes. So now does it just looks like a pipe or not? Yes. So this type of failure is known as a piping failure. This type of failure is known as piping failure. So this entire soil mass will be settled as a here as a heave. So this is going to be soil heave due to erosion. And once what happens over here, sir? See, once it is going to be create a larger path, you see this is going to be the path of the soil mass or not. Now this entire water will start to travel immediately through this path. When the entire water starts to travel immediately through this path, then on the upstream side, the upstream water level fall down. On the downstream side, the downstream water level is going to be rises. The downstream water level is going to be rises. So this is A here, this is B here. This is A here, this is B here. Now, what I want to convey over here is, listen to the condition clearly. See, whenever the upward pressure is more than the downward pressure, which means whenever the quicksand condition is going to be exist, so due to this upward force, the soil starts to erode upside, and it is going to be progress towards the backward. See, it starts at first over here, and then it is going to be progress towards the upstream. So it progress towards the erosion is going to be progress towards the upstream. This is erosion, Nana, and flow is going to be progress towards the downstream. So once it reaches over here, you see large amount of the soil has been eroded or not. Due to this large amount of void space, means you can see a lot of space is there or not, then the flow is going to be passes through this space with more velocity, so that the upstream water level falls and downstream water level rises. Then the purpose of the dam is no more. Then what is the purpose of the dam? What is the purpose of the dam? To store the water. When the entire water will travel to this, then the dam will fail or not? Obviously, the dam is going to be fail. Such a failure is known as a piping failure. So just give me a minute. I will show you some video also. Everyone have a look. I hope everybody is able to see this one. Yeah, suddenly. Okay, fine now. Let me check it, please. Give me some more time, please. Now, everybody, please look over here. I hope now it might work. So, please have a look, everybody. So now, if you see, so just have a look over this one. Yes, everyone, what I'm showing you over here on the desktop bar of your here is, you see clearly here, you observe clearly, whatever this portion you see here, this is nothing but a flow, right? Yes. So here they are clearly showing there is a flow inside of a soil mass. There is a flow inside of a soil mass like this. Yes. So now on the downstream side, due to this quicksand condition, slowly the soil starts to erode. If you observe clearly, where it has started first on the downstream side, because here this is going to be gamma dash into Z, here gamma W into H. When the upward force is going to be more than the downward force, factor of safety is nothing but IC by I. When I is greater than IC, then factor of safety is going to be less than 1. Then the failure is going to be happen. So what is the factor of safety? How I got this equation? I got this equation as gamma dash into Z by gamma W into H. So now, if you see here, whenever the upward force is less than the downward force, now this will induce an upward force, then slowly the soil starts to erode from the downstream side. Now you please observe how the flow pattern is going to be happen clearly. You please observe here, slowly. Now you see, slowly on the downstream side, while the flow is happening, on the downstream side, the soil mass is going to be gets eroded, and this erosion path, whatever the erosion path it is, this is the erosion path or not? And this erosion path is going to be progressing towards whom? Upstream side. This progressing is going to be towards the upstream side. And you see, observe. Observe. As you know, this is nothing but V is equals to Ki, right? Hydraulic gradient. Whatever I am representing the I value, factor of safety, you know that the factor of safety IC by I, when I is going to be more than IC only, this condition will arises. So now, you see, slowly, as this path is going to be increasing towards here, on the downstream side, if you observe, what is this? What is this over here? Soil heap. If you observe over here, this is nothing but soil heap after erosion or not? Yes. So now, yes. See, up to this point, what has happened? Just a minute. Yes. So now you please observe the flow movement over here. So as this erosion path is going to be takes place up to the upstream. Now, so up to this point, the flow movement is going to be slow. But once it reaches to this point, immediately what is going to be happen? Immediately the flow path is going to be increases and the downstream water level, upstream water level is going to be decreases and decreases and decreases. See, and now this is going to be the actual. This is going to be the actual. I'll show you again over here. You see, observe slowly. Again. Slowly, the entire soil mass beneath the dam is going to be removed, and you can see the soil heap is going to be more and more and more, and the upstream water level is going to be decreases. On the downstream side, the water level is going to be increases, or the entire water will be infiltrated into the soil mass like this. So now, yes, you see, in this case, this is an experiment made in the laboratory. What is going to be happen due to this seepage? Observe from here. You see, due to the seepage, what is going to be happen? The entire downstream bed is going to be collapsed or not. So due to this upward seepage, the entire soil is going to be gets collapsed, and whatever the dam you are going to see here it is fixed up. But in reality, the dam, if you observe clearly, is there any in this zone? Is there any support? No support to dam. When there is no support, then this dam will collapse or not? Then this dam will collapse. So whatever the soil erosion I have shown you, that is going to be the piping failure. So this one you can get it as a quicksand condition. If you go for the YouTube, there is a one site, practical engineering. You can go through this one. So the practical engineering, if you search a quicksand condition, you will get this video for 5 minutes. You please go through that video. So this is what the quicksand condition and a piping failure. So in other words, now by showing you the figure, I'll tell you. In other words, I can say piping is a failure or backward erosion from the downstream towards the upstream. From the downstream towards the upstream due to quicksand condition. So it's a simple soil erosion starting from downstream, moving towards the upstream. So that's how I hope I made you to people understand this one. So if you still have any doubt, you please go through that video. If you still have any doubt, you please go through the video in YouTube. Practical engineering. There is a video how quicksand occurs. So That is just a 5 minutes topic. Whatever I have explained over here, everything is going to be present over there. So now you see that's what I am showing you here also. Whatever I represented here also, this is going to be the soil erosion moves from downstream to upstream. Then immediately the entire water is going to be flows with a larger velocity. Then the upstream water line is going to be falls down. On the downstream side, the bed is going to be collapses. This entire bed is going to be collapses. So now, what is a piping failure? The piping failure means erosion of a soil mass progressing from downstream to upstream due to quicksand condition. So erosion of a soil mass progressing from downstream to upstream condition due to quicksand condition. See, in order to undergo the piping failure, first of all, soil should be under quicksand condition. Keep that in your mind. Without quicksand condition, there is no piping failure. So now, RSR, if this is the case, can't we prevent the piping failure? Now, there comes. Once we know that type of failure, as an engineer, what we have to do is we need to prevent the failures. So how we are going to prevent the failures? Is there any piping failure in reality? Yes, I'll show you that also. In reality, I'll show you a lot of things were there. So generally on the downstream side, there will be concrete bed. No, sir, even though the seepage takes place. See, concrete bed is there, but concrete bed is not going to be constructed over a kilometer's length, right? The concrete bed on upstream and downstream would be there, but seepage will be takes place through the soil mass. And after the concrete bed, it is going to be create the seepage. Now, I'll show you as you asked people. You see the same here. Failure occurs. Yes. Now, with this, you see, these are the failures, Nana. These are the failures, some of the failures due to the seepage. See, you please go through this video, you will get to know that what are the type of, means wherever you see the failures also. So now, yes. So now coming to the preventive measures. Preventive measures is, now have a look everybody. See, generally what is the factor of safety? IC by I. Yes or no? So now you know when I is going to be less than IC, then it is going to be safe. When I less than IC, then only the soil is going to be safe. So as an engineer, so what we know is we have to make sure the hydraulic gradient on the downstream side, whatever the hydraulic gradient on the downstream side, because there is upward seepage or not, that hydraulic gradient should be less than critical hydraulic gradient. Okay. So what is the hydraulic gradient, sir? H by L, or let's take H by Z, because it's a vertical seepage, right? Vertical seepage means the length is going to be the depth of the soil. Now, I is equals to H by Z. Everybody, as an engineer, are we going to design for high factor of safety or low factor of safety? High factor of safety. When you want to go for the high factor of safety, then you see I should be less than IC. Does IC is going to be changes? No. What is IC? G minus 1 by 1 plus C, which means IC is constant. For a given soil, G is constant and E is constant. So IC is going to be constant. So this factor of safety entirely depends upon the I only. The factor of safety entirely depends upon the I only. So now, if you want to design this safely, then you have to make sure the I should be less than IC. For lesser I, what you have to do, please tell me. If you want to make sure I as less, what you have to make sure? Either you decrease the head. So this is H by Z. If you want to lower the I value, either you should decrease the head or you should increase the length of the C phase. So if you increase the length of the C phase, you see, if you increase the length of the C phase, then I value will be less. If you decrease the hydraulic head, then I value would be less. So, or both can be also happen. So now our main intention is to reduce the hydraulic gradient. And in order to reduce the hydraulic gradient, the possible ways are to increase the length of C phase, to increase the length of C phase, or to decrease the hydraulic head. So for that, number one, increasing the C phase length by increasing base width of dam. If you observe, if I go for more base width of the dam, if I go for more base width of the dam, you see this is the base width of the dam. This is the width of the dam or not? So let's take this is a width of the dam. Arey Baba, if the width of the dam is going to be more, then the water has to seep a more length or not? Then definitely from the starting point to the ending point, the length traveled by the water is going to be more. The length traveled by the water is going to be more. But the question is, just imagine, if you provide a more width, then what about the cross section of the dam? Increases, yes or no? So if you provide the width, more width, then the cross section of the dam increases. Is it economical or uneconomical? See, as a civil engineer, not only we design for the safety, but also we have to design in an economical way. So if you go for the dam width, then the dam cross section is going to be more. When the dam cross section is going to be more, then the amount of the cost required to construct the dam would be very, very high. So here it's uneconomical. This is generally uneconomical. So wherever means the countries which are richer countries, they can opt for the base width of the length, or the poorer countries, they cannot go for this one. So then what may be the other possible ways, sir? The second possible way and very good way is by providing cutoff wall, or we call it as a sheet pile wall on downstream side to increase the seepage length. You observe here. Now let me draw that figure again. Now, everybody, you see here, what I am going to draw on the downstream side. I will provide this one. See, whatever this is nothing but this is a sheet pile wall. This is a sheet pile wall. So this is a sheet pile wall. Actually, you see, this is the cross section, right? Along the dam, then you're going to provide a sheet over here, but because we are not discussing about the 3D, we discuss only the 2D. So forget about this one. Then you see here. So once I provide this one, you observe carefully, this is upstream and this is a downstream. This is upstream water level and this is going to be the downstream water level. So now, generally the flow should be like this. This is going to be without sheet pile wall. Yes or no? This is without sheet pile wall. But now with the sheet pile wall, what happens over here is the seepage is going to be travel beneath the sheet pile wall, because the sheet pile wall won't allow the water to pass through it. Understood or not? So this is a sheet pile, just like a sheet, which is going to be a pile. So now the seepage is going to be goes in this fashion. So now if you observe over here, see, this is with the sheet pile. So this is with the sheet pile. So what happened ultimately over here is, compared to this blue line, then obviously on the downstream side. So now when I proposed the sheet pile wall, the length the water has to travel is going to be increases or not? Yes. You observe this length is going to be increases. So when the length is going to be increases, see here, Z is going to be increases. It increases the seepage length. When Z is going to be increases, I value decreases, so as to make I less than IC. I less than IC. So not only that one, but also you see, but some of the students may ask me, sir, can't we provide the sheet pile wall on the upstream side? No. If you provide also, see, if you provide the sheet pile wall on the upstream side, does upward seepage happens on the upstream side or downstream side? Downstream side. So now if I increase this length, what happens? The downward pressure is going to be more than the upward pressure or not? Yes or no? See, when you increase the length on the downstream side, when the Z is going to be more, what is the downward pressure over here? When this Z is going to be more, now you observe, when the Z is going to be more, what is the downward pressure? Gamma dash into Z. So if I provide a sheet pile wall on the downstream side, it increases the length of the seepage. So now when the length of the seepage is going to be increases, then the I value is going to be decreases. So, and not only that, what is gamma dash into Z? Submerged pressure, which is resisting. Resisting is also going to be increases. When Z increases, gamma dash into Z increases. So that's it. So this is a second one, by providing a cutoff wall or a sheet pile wall on the downstream side to increase the seepage length. So now the third one is by providing inverted filter on downstream bed of dam to reduce the hydraulic head. To reduce the hydraulic head. Sir, how you are going to reduce the hydraulic head? Have a look again. You please observe here. Here in this zone, I did not change the hydraulic head. This is the hydraulic head. Yes or no? H. I did not change the hydraulic head, but I simply increase the length of the seepace. So now, what I'm going to do is I'll reduce the hydraulic head. When I reduce the head, means hydraulic head or seepace head or a total head loss at the end, then I value is also going to be decreases or not? Yes. So now, to reduce the hydraulic head, what I'm going to do is I'll be providing the inverted filter. So for this, so again, if there was an option that we can copy, that would be much more better. But fine, how to go this one? No other option. I need to draw the figure again. Now, you see, there is upstream water level. And now if I provide sir, how we construct the cutoff wall? See, while you are constructing the structure, foundation would be there or not? Do you know the pile foundation? Yes. So we are going to insert a pile first and then we construct a foundation on the top of pile. Similarly, first we insert the pile, sheet pile, and then we are going to lay the foundation, and on that foundation we are going to construct the dam. So now, if I go for this inverted filter on the downstream bed, how I am going to show you here, have a look. So on the downstream bed, now I am going to show you, means what I am showing you here, this is the downstream bed. So I am going to provide a filter over here. So how does this filter looks like, sir? I told you this is an inverted filter, right? Yes. So as it is an inverted filter, that inverted filter means there exists 3 layers. So now, if you observe, I told you in the previous session that quicksand condition occurs in the case of fine sands and silts. So let's say this is going to be fine sand or silt. Now this is this is the upstream water level and this is going to be the downstream water level. Let's say before the upstream water level, means before this inverted filter, this was the water level. Means if I don't provide the inverted filter, I'm telling you this is the higher water level. So now what happens due to this inverted filter, sir? What is the meaning of filter, sir? Filter means to allow the water to pass, sir. To allow the water to pass. So now if you observe clearly, what is going to be happen over here is in this inverted filter. So my simple point is I have to reduce the hydraulic head. How can I reduce the hydraulic head? I have to raise the water level from here to here. This is a position number 1 and this is a position number 2. When I raise the water table, then the hydraulic head is going to be decreases from this point to this point. So this is, let's take it as H1 and H2. When the hydraulic head decreases, then I value decreases. So our point is to rise the tailwater level. When you raise the tailwater level, obviously the difference between water levels will be decreases. When the difference between water level decreases, then hydraulic head decreases, then I value decreases. So this is our main phenomena. Now you observe here. For that, what I do is I'll improve the permeability of the soil. I'll improve the permeability of the soil. So now here, what we are going to provide is, at first, in the bottom layer, there is a soil mass which is going to be medium sand. Medium sand. See, you tell me, whatever this soil mass is going to be fine sand or silt, right? This is a soil where fine sand or silt. So now you know that the seepage will take place through this one up to this point. See, the seepage up to this point depends upon whom? The permeability of the fine sand and silt. Generally, you go further. Generally, if it is going to be fine sand or silt, due to low permeability, the level of water on the downstream side would be very less. But if I provide a medium sand over here, this is fine sand. Medium sand permeability is more than the fine sand, because you know, larger the dia, more the permeability. Now you tell me, does the water enters into the medium sand freely or not? Yes. So this water will enters into the medium sand freely. Then again, in this layer, we are going to provide this as a coarse sand. It has a coarse sand. So now you tell me here, see, this is a bottom is a medium sand, above is a coarse sand. When the bottom is medium, above is coarse, then this coarse sand permeability is much more than the medium sand. Then this water level will enter into the coarse sand easily. And the top layer we are going to provide with the gravel. This is gravel. And you know that gravel permeability is going to be very, very larger than the coarse sand. So now, in this case, the water will seeps out easily, and the more the water will enters into this filter, the level of water level is going to be rises from 1 to 2. This is without filter, and this is with the filter. So now, then the hydraulic head or the difference between the water level starts to decreases. When H decreases, when capital H decreases, then the small h decreases, then I value is going to be increases. So what I have done over here is, I just removed the soil on the downstream side where the upward seepage is going to be takes place. I just removed that soil on the downstream side where the upward seepage is going to be takes place, and I provided with a high permeable soils. And in such a way, so can't I provide the coarse sand at the bottom, gravel on the bottom? See, while you're designing, there are some specifications. That specifications are, while you are allowing, the water will go out, but not the soil particles. The water should go out, but not the soil particles. Listen to me. What if I reverse this position? If I reverse this position, for example, if I would have provided here as a gravel, so here I decreases, sorry. So now, if I would have provided this as a gravel, let's say, if I would have provided this as a gravel, are a gravel void space is going to be larger or not? When the gravel void space is going to be larger, it will allow water. But at the same time, the fine sand or silt particles are very, 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 very small. So if you provide a gravel at the bottom layer, what happens over here is simply I can say not only with the water, along with the water, the soil particles will enters into the filter. When the soil particles enters into the filter, it will blockage the flow. Then again, there is no provision of, means there is no usage of providing all these things. So it should be medium sand. So now I can say this inverted filter, this entire is going to be the inverted filter. See what we call this one as this is an inverted filter. So inverted filter, so it's a inverted filter. It has low permeable layer on bottom and high permeable layer on top. Low permeable layer on bottom, and mind it, see I am arranging in this way. The bottom soil should be the top soil must be permeable than the more permeable than the bottom soil, which means the bottom soil size is going to be, the top soil size is going to be more than the bottom soil. So now for this there are some specifications. The specification goes as you see, observe here, let me draw this again. So whatever this is medium sand, here coarse sand, here this is gravel. So while you are taking this one, if you see the first layer, for the first layer you observe this is going to be filter and the bottom is going to be base. Whatever the bottom is going to be fine sand or silt or not. So this fine sand is going to be base and medium sand is going to be filter for the first layer. Then if you go for the second layer, see this is a second layer, right? In the case of the second layer, now this is going to be the filter and the bottom is going to be the base. See what I want to say over here is, in this filters, bottom layer is going to be the base, top layer is going to be the filter. The bottom layer is going to be the base and top layer would be the filter. So here, now the specifications for design is whatever the, see you know that medium sand size is going to be more than the fine sand, yes or no? Then how much, sir? You see the D15 of filter. What is the meaning of D15 of filter? The particle size which is finer than 15% in the filter means for the first layer, who is the filter? Medium sand. For the first layer, medium sand D15 and D15 of base is greater than 5. So what is the meaning of this one? You please observe, the filter size should be more than 5 times of the base size. The filter size would be more than 5 times of the base size. So D15 of filter is greater than 5 times of the D15 of the base. So filter size is more than the base size. When filter is size more than the base size, then the permeability is more, then it allows the water to flow freely. To allow water percolate towards downstream. This is one specification. And the other specification is D15 of filter by D85 of base is less than 5. See, these are the specifications made by code. From the code it is taken, so it is not the one that I have taken. For everything there is a code. Similarly, soil has some code. So forget about the code name, because there are a lot of codes as a type of experiments changes. There are a lot of codes for the soil exists. But in the case of the concrete, you know the code, and in the case of the steel, you know the code. IS 456 2000, so IS 2007 means 2008. For steel and concrete has a different codes, right? So similarly, soil has multiple codes. From the codes, when the 15 size, the minimum size of the filter should be less than the 5 times of the maximum size of the base, so as not to uh, prevent escape of soil particles. So now, while we are designing, we have to keep these two on our mind. One is the minimum size of the filter should be more than 5 times of the minimum size of the base, so that the water will allow easily. And second one is the minimum size of the filter should be less than 85, 5 times of the 85, D85 of the base. This is for the first layer. Then what is for second layer? For the second layer, who is the base? Medium sand. Who is a filter? Coarse sand. For the third layer, who is a base? Coarse sand. Then who is a filter? Gravel. So you have to make sure the bottom is base, above is going to be filter. If the bottom is fine sand, above is going to be filter as a medium sand. If the bottom is medium sand, above filter is coarse sand. If the bottom is a coarse sand, then the above filter is going to be gravel. This is how the designation has to become. And once it happens, then this is the condition we are going to see. Then obviously I is going to be decreases. Then these are the preventive measures. Every preventive measure they have been asked in a previous IES as a bit. That is the reason why I took a lot of time for make you understand over here. I don't need to intend to do this, but it has happened. So you please go through that once again. Please give. Meanwhile, you please go through it. I'll come within 2 to 3 minutes, please. Yes. So I'm back. Sorry for make you wait. Sorry, if we're stuck into quicksand condition, will we die? No, we won't die, but our fear make us die. So I think means if you go to the YouTube, this quicksand condition is there. So you please go through that. There is one video also. I have seen that video made by Bear Grylls. Please go through that. Sir, without using filter also the water level on the downstream side is going to be increased. So automatically H will decrease. Then what is the difference between using filter and not using the filter? See, if you use the filter, the permeability is going to be more. The more the permeability, see, without using filter, the water level will rise up to this point only. But if you use filter, the water level will rise up to this point. That's what I mentioned. Without filter, up to this level, water level rises. But with the filter, the more the permeability, the more the water will go out. So to allow water percolate to allow more water to percolate downstream. Scouring is different and erosion is going to be different. Yes, but in macro terms, both are going to be same. Remember, but our main aim is to store more water. Some of the student is asking, sir, our main aim is to store water in the dam. What is the benefit of providing inverted filter? See, except a safety, there is no provision. See, while you are going to design the dam is to store the water, but the dam is resting on whom? Soil. If the soil fails, kya hota? The dam is also gone. If the soil fail, you see, the piping failure is not a failure of the dam. The piping failure is a failure of the soil. Okay. So when the piping failure occurs, then the entire water level goes out. Then there is no provision of storing a water. So sheet pile wall made of concrete or geosynthetic materials. You can use both. Is a filter should have only 3 layers or can be more than 3? Sir, generally we prefer 3 layers. Sir, how to prevent seepage in earth dam, sir? That we will discuss in the next chapter. D15, Arey Baba, you don't know, don't you know that D10, D30, D60, the same way D15. D15 means particle size below which 15% of the soil is going to be finer soil. Sir, if we arrange a top layer with clay, what happens, sir? Sir, if you arrange the top layer with clay, then what is the permeability of clay, sir? Very less, sir. Will it allow the water to the downstream side? No, sir. If you provide a clay, then it won't allow the water to the downstream side. When you don't allow the water to the downstream side, then the hydraulic head is going to be much more high, sir. Sir, why Hazen has given only D10, D30 and D60 and why not D50? You please go through the previous classes, sir, then we will get that. Why we will select D85 and D15? See, there is no exact reason for that. That's based upon the empirical relations given by the code. See, in the case of gold, everything does not have any exact relations. Those are based upon the empirical details. The remaining things you will be discussed in the case of the irrigation. See, in irrigation, there is a one chapter for you. Stop your questions now. It's been too late. So far, a lot of questions has been asked. See, in irrigation, there is a chapter known as diversion head works, there again you are going to see all these things. Piping failure. Actually, this condition should be discussed in the irrigation. But as I am a soil faculty, I am discussing all these conditions. In the case of irrigation, you are going to see the cross section of weir. At the bottom of the weir, there is an inverted filter. There is a boulders. There is a like a apron, launching apron would be there. So all those things in irrigation, there is a one chapter known as a diversion head works. There you are going to see all these things, the different type of failures. But as a faculty, I have to say now I have introduced all these things. Okay, now let's go for the next thing. Please stop your. So still I did not understand what is the purpose of providing filter. I have explained it, Mr. My dear. You please go through the video once again. Now, note. Stop your questions and listen now. Note. This quicksand condition also occurs when a trench means a small excavation, when a trench or pit, when a trench is excavated below water table and made the excavation free of water. So when a trench is going to be excavated below water table and made the excavation free of water, then also we are going to see the quicksand condition. So look over here, observe this carefully. Now let's take this is the ground level. Let's say this is a ground level, and if there is a shallow water table, if there is a water table which is very shallow means which is very near to the ground surface. So this is a water table, and let's say somewhere below there is a hard strata. Somewhere below there is a hard strata like this. So now what happens over here, sir? So what is the meaning of this quicksand condition occurs when a trench is going to be excavated below the water table and made the excavation free of water? You see, in order to construct a structure, first what you have to do? In order to construct a structure, first what you have to do? You need to lay a foundation. For the foundation, what we have to do? For the foundation, we must have to provide the excavation or not? Yes. Now, you see, I start to do excavation. When I start to do an excavation and I progress towards the downstream, you see, I am progressing towards the downstream over here. So let's say I have progressed up to this point, right? See, this is an excavation that I have progressed up to this point. So are you going to excavate the total soil at a time? No. You excavate the soil mass from top to bottom, layer by layer. So I remove the soil mass here. By the time I reach over here, now this is going to be the excavation. Yes or no? Yes. So when it is going to be the excavation, then the water level here, this is going to be the water level. Okay. But up to this point, is there any change in the water level? No. So this is an excavation. And in the excavation, now I just reached the level of water table. I just reached the level of water table, but there is no difference between the water levels. Now you see, This is a condition occurs when a trench, this is a trench excavated below the water table. So now what I'm going to do here is, so if I excavated beneath this one, let's say you have excavated up to this point. And now let's see, if I excavated up to this one, is it going to be below the water table or not? Yes. And now you tell me, Are Baba, when you excavate below the water table, then definitely you are going to make sure this entire excavation is free of water or not? Yes. When this excavation is going to be free of water, now this is going to be the water table. You please everybody tell me here, then immediately what happens over here? There is a difference in the water level or not? When there is a difference in the water level, within no time, this water starts to seeps over here. And this water starts to seeps over here. When it starts to seeps, then this entire excavation is going to be filled with water again and again and or not. So no matter how many times you are going to provide the excavation free, then due to the difference in the water levels, then definitely this water will enters into the excavation. So when you are going to provide an excavation below the water table and made the excavation free of water, there is an upward seepage. When there is upward seepage, then this entire soil may get eroded like this, and it causes the quicksand condition. What is the meaning of quicksand condition? Soil will behave like a liquid. When this water enters into the excavation, then the soil will be behaves like a liquid, not as a soil. So what is the prime preventive measure for this one, sir? What is the prime preventive measure from this one, sir? Sir, what happens is preventive measure. The preventive measures are, number one, by lowering the surrounding water table. Using dewatering techniques. See, there are some dewatering techniques. Those dewatering techniques are like electro-osmosis method and electro-osmosis method. So there are some methods to pump out, pumping methods, electro-osmosis methods. Those are going to be provided to lower down the groundwater table. You see, before the excavation itself, if I lower down this water table up to this point, before the excavation, if I lower down the water table up to this point, now you tell me, if I lower down the water table, then the water level is going to be same, right? When the water level is going to be same, then you tell me what happens. There is no seepage, no quicksand condition. So this is one preventive measure. Now you observe clearly. The other one is, second one is by providing sheet pile walls on sides of excavation up to hard strata. If we provide a sheet pile wall, now let's see. You observe. Now, if I provide So now, when I provide a sheet pile wall on both the sides, observe, this is a sheet pile wall. Now what happens is, just because the same way in the piping failure, what we have done, when you provide a seepage, you see, these are the difference between the water levels. Whatever the difference between the water levels will create a head of H. Yes, will create a H of head. So now, due to this, the seepage will not take place directly. Then the seepage will start to take place beneath the sheet pile wall. Beneath the sheet pile wall. Now, let's say, the depth of the soil mass below this excavation. Let's say the depth of the soil mass below the excavation is going to be Z. And you know that below this water table, entire is going to be, now this is going to be upward seepage or not? Yes. As this is an upward seepage, from here onwards, the water starts to move in upward direction. The water starts to move in an upward direction. Sir, what is the purpose of this sheet pile wall, sir? Sir, when you provide this sheet pile wall, earlier, the water used to flow directly into the excavation. But now the water has to travel along the length, so that now this water will move over a length of Z. When it is going to be length of Z, now you tell me the downward pressure here, the downward pressure is going to be gamma dash into Z, and the upward pressure, existing upward pressure due to this seepage. Due to the seepage, this is going to be gamma W into H. So now, when I provide a sheet pile wall, then there is a counterbalance force, which is nothing but downward force, and there is an upward force. Then what is the effective stress here? Effective stress is equals to gamma dash into Z minus gamma W into H. So this is how the excavation. See, quicksand condition also occurs when a trench is excavated below water table and made the excavation free of water. Now, when effective stress is equals to 0, then quicksand condition comes into existence. Quicksand condition comes into existence. Sir, how come we know the length of the sheet pile wall, sir? How come we know the length of sheet pile wall means, sir? You see, what is the length of the sheet pile wall? Let's say the depth of the excavation as X. Let's say the depth of the excavation as Y, because this is Y direction, and this is the difference between the water levels as a H. Difference between the water levels as H. So now let's say Y is depth of excavation. So now my question is, what is the maximum depth of the excavation up to which no change in the water level, or up to which no quicksand condition exists? So now, for no quicksand condition, the maximum depth of excavation B. So you know that yet critical condition, the downward pressure is equals to upward pressure. When the downward pressure is equals to upward pressure, what is the downward pressure? Gamma dash into Z is equals to gamma W into H. So what is Z value? You observe here. Now let me take this as a total depth as D. Now, what is y over here? I can write, y is equals to d minus z. So now I can write z is equals to d minus y. I can write gamma dash into d minus y is equals to gamma w into h. So in simple words, remember one thing. If I ask you the maximum depth of excavation, what is the maximum depth of excavation? Wherever the downward and upward both are same, that is the maximum depth of the excavation that you can do. If you go beyond that excavation, kya hota? Now you tell me, everybody, if you observe, sir, if I go excavation up to this point, sir, if I go excavation up to this point, sir, what happens, sir? Then the difference in the water level is going to be increases, sir. When the difference, see, everybody, please listen to this one. When I go the excavation from this point to this point, sir, then the difference between water levels is going to be increases, sir. When the difference between water level increases, then upward force is going to be increases, or upward pressure increases. Then what happens to depth, sir? The depth is going to be decreases, sir. Initially, this is the depth, sir. Now this is going to be the depth, sir. Then the downward pressure is going to be decreases. So now, when you go beyond the maximum depth of excavation, what happens? If you go beyond the maximum depth of excavation, then the head is going to be increases, upward pressure increases. Z is going to be decreases, downward pressure decreases. Downward pressure less, upward pressure more. Then the water will heave into the soil mass. Now you can see there is a heaving at the base of excavation. So now, if excavation is done beyond this depth, soil will heave at base of excavation. Sir, I don't want to remember this formula, sir. Sir, you don't want to remember this formula, or simply effective stress is equals to total stress minus pore water pressure. So whenever the quicksand condition occurs, then total stress is equals to pore water pressure. When effective stress is equals to 0, quicksand condition occurs, then effective stress is equals to total stress minus pore water pressure. So total stress is equals to pore water pressure. So this is one case. You please observe over here. Just simply, how to find out the maximum depth of excavation? The maximum depth of excavation means that is known to be the critical condition. Yet a critical condition, downward is equals to upward. What is downward? Gamma dash into Z. What is upward? Gamma W into H. If you equate both, then you can get the same answer. Okay. So now, sir, from this sigma is equals to U also, I can get the same thing. You observe. When effective stress is equals to 0, then total stress is equals to pore water pressure. So now you go back and tell me what is the total stress at this point? What is the total stress at this point, please? Forget about all these things. What is the total stress at this point? The total stress at this point is whatever the unit weight gamma sat into Z. Whatever the unit weight gamma sat into Z. Gamma sat into Z. See, this is the logic I'm wishing you to understand this one. When I say effective stress is 0, total stress and pore water pressure is going to be 0. Is equals to gamma W into HP. So what is HP, sir, here? What is HP? You please tell me. If you insert a piezometer, whatever the water level rises in the piezometer, this is nothing but the HP. Yes, this is going to be the HP. So now from the figure, can I write the HP is going to be H plus Z? I can write gamma sat into Z is equals to gamma W into H plus Z. Gamma W into H plus Z, because this is H, and this is the Z value. So what is this HP value? HP value is going to be H plus Z. So now I can write this HP as H plus Z. So if I write this one as HP plus H plus Z, gamma sat into Z is equals to gamma W into H plus gamma W into Z. Take this outside, then gamma dash into Z is equals to gamma W into H. What about this condition is going to be same or not? Yes or no? This condition and this condition both are same. So when I equate these two, then definitely from here to here, it is going to be same, right? Either you can use gamma dash into Z is equals to gamma W into H, or you can use sigma is equals to U. So I hope you understood this point over here. So I hope you understood this point clearly. So if you have understood this one, then you can get down any answers. I'm telling you with ease. The point that you need to know here is, in order to not to cause the excavation failure, whatever the downward and upward should be same. And if the downward is less than the upward, then there is a heaving. Or if upward is more than the downward, then there is a heaving. So make sure the critical condition. I'm telling you this is logic again and again and again and again and again. If there is an excavation, make sure for no failure, the maximum condition is critical condition, which means effective stress is 0. And condition number 3. Condition number 3. If an excavation is made, into a clay stratum underlined by sand. Stratum, under means below, which is having artesian pressure. Also has quick condition. So if you make an excavation into a clay stratum underlain by a sand stratum which is having artesian pressure. So now what happens over here, sir? Again, please have a look. You see, this is a ground level, and the center is going to be a clay soil, and beneath this there is a sand, You know the meaning of the artesian condition, and beneath this there is a rock or some other layer, but this sand layer is in artesian condition. So artesian condition. Whenever there is an artesian condition, then definitely somewhere there is an artesian pressure, because this is a water bearing strata, right? There is going to be artesian pressure. What is this PA? Gamma W into HA. So now if I insert a piezometer or artesian well, I hope you remember that in yesterday's class itself we discussed all those things. This is an artesian well. Now whatever the water level rises into this artesian well up to a certain height, see, it can be below the ground level or it can be above the ground level also. If you want, you please go through the yesterday's session. So let's take this is an artesian head as a HE. So now you tell me What is the total uplift pressure here? This is nothing but uplift pressure or upward pressure or not. Gamma W into HA. Gamma W into HA. And this is going to be counterbalanced by the weight of the soil. Counterbalanced by the weight of the soil. So what is the weight of the soil mass? Let's take again, if D is the depth of the clay. Now I am going to excavate. See, if an excavation is made into the clay, what happens over here? See, now I am going to make an excavation. If I do make an excavation up to certain depth, what happens due to this excavation, sir? See, I did not say to you there is a water level in the clay layer. Whether it is there or not, because this sand is going to be, see, this sand somewhere may get attached like this. This sand somewhere may get attached like this. And there is a rainwater. Due to this rainwater, the water will be enters into the sand layer, which is going to be create the artesian condition. So this is a clay, and let's say below there is also going to be clay. So now this sand is under artesian condition or not? Because this is a sand, a permeable layer present between two impermeable layers. So this water will seeps over here and it is going to be create an artesian condition. So I just take this position now. You see, here, as the depth of the excavation increases, let's say Y, and the soil mass depth is going to be decreases. Yes or no? Yes or no? Now you please tell me, what is the downward pressure over here? Gamma into Z. What is the total upward pressure over here? Gamma W into HA. Now, the question is, Are Baba, this uplift pressure try to lift up the structure or not? Yes, it tries to lift up the structure. Now, when you do an excavation, as the depth of the excavation is going to be increases, this Z value decreases. When you do more excavation, you are removing the weight of the soil or not? When you remove the weight of the soil, the downward pressure will decrease. The downward pressure will decrease. When the downward pressure will decrease and the upward pressure, there is no change in the upward pressure. But when this downward pressure decreases, when these two are going to be same, then what is effective stress? Zero. When effective stress is going to be zero, then again there is a critical condition or not? So, yet critical condition, what is effective stress? Effective stress is equals to zero. Then total stress is equals to pore water pressure. The total downward pressure is equals to total upward pressure. So what is the total downward pressure here? Please tell me. What is the total downward pressure? Gamma into Z is equals to gamma W into HA. See, sir, you said one formula here. You said other formula here. You observe here, I took the same formula and I made sure the same equation. Either I want to say, either I can write in terms of this form or I can write in terms of this form. Any form you write, you get the same answer. Keep that in your mind. Keep that in your mind. So I simply go for every time, whatever the total downward pressure, total stress, and total upward pressure, pore water pressure or artesian pressure. So when these two are going to be same, then gamma into D minus Y is equals to gamma W into HA. You know HA and you know D, you know gamma, we can find out the Y value. So this is our condition, and this is condition number 2, and this is a condition number 1. So these are very, very important in the case of the examination. Please go through this once again. See, there is a seepage here. There is a seepage. But here there is no seepage. This is just an artesian condition. Understood? Let's go through this. Now I'll be solving the questions. So if I solve the questions, then you can understand much more better. What is the purpose of making trench? I told you, where you people are, if you want to construct a structure, where you are going to construct a structure? Are you going to construct the structure on the ground level? Are you going to construct your foundation on the ground level? No, right? You have to dig an excavation. That excavation is nothing but trench. Have you ever seen the construction of a structure? Then definitely, then there must be some holes created or not. That is nothing but an excavation. That is known as trench. So dewatering techniques are there. Dewatering techniques means the dewatering pumping methods and electroosmosis methods that we see in ground modification techniques for the ESC. So as of now, you don't require that. Yes, I have written this one, downward pressure. See, I can write in this fashion. You see, observe. When I write gamma dash, you please everybody have a look. When I write gamma dash, you observe here. When I write gamma dash, then H is going to be seepage head. Okay, the H is going to be a seepage head. But when I write gamma sat, the H is going to be pressure head. So if you want to understand, you please go through this one. I have written the same thing. The pressure head is going to be taken as depth of the soil plus seepage head. So if you take this one, gamma sat into Z minus gamma W into Z. See, I have observed, I have given you clearly, you can either go by this equation, you get the answer, or you can either go by this equation, you get down the answer. But when you go gamma sat, you have to use HP. When you go gamma dash, you have to use a H, which means when you go for the total stresses, this is a pore water pressure. When you go for the effective stress, this is the seepage pressure. You please make sure. Yet a critical condition, effective pressure is equals to seepage pressure and total stress is equals to pore water pressure. Both are same. I have given this derivation. Please look over here. Don't ask me, sir, why are you using gamma dash and gamma sat? If I use gamma sat, HP. If I use gamma dash, H, the same condition applies over here also. Won't H rise above in, sir, if this is an artificial condition, won't H rise above the ground level? Yes, it can rise, but it depends upon the ground level, right? It depends upon the ground level. That's the reason why I did not discuss that. Yes, this HA means artesian head only. This HA means artesian head. Okay, now I hope you have seen this one. Now let's solve some questions regarding to this one. Listen. If you understand this topic, everywhere the common point I'm mentioning is this effective stress 0. Here also effective stress 0. Here also I mentioned effective stress 0. When effective stress 0, total stress is equals to pore water pressure. Or gamma dash into Z is equals to gamma W into H. You can use both. Either you go with the total stress is equals to pore water pressure, or you can go with this one. Both are same. Both are same. So you don't need to worry about so where to use this one. Now let's solve some questions regarding to this one. The major condition for the quicksand condition is effective stress should be 0. Without effective stress 0, though the soil is cohesionless soil, there is no quicksand condition. So now let's solve questions, please. So you please look over here. These are the previous gate questions at first. So I hope you can see this gate. This is chapter number 8, gate questions, previous gate questions. So now you please everybody have a look. The relationship between the specific gravity and the hydraulic gradient to initiate quick condition in the sand layer with the porosity n is equals to 30%. So when the porosity is going to be n is equals to 30%, the relation between the specific gravity and the hydraulic gradient. You know that IC is equals to G minus 1 by 1 plus E, or G minus 1 into 1 minus N. So they have given the porosity, right? So now IC is equals to G minus 1 into 1 minus 0.3. 1 minus 0.3 means 0.7. So IC by 0.7 is equals to G minus 1. And if you solve this value, then G is equals to 1.43 IC plus 1. Here they mentioned the hydraulic gradient as I. Simply you can take it as a IC. So the relation over here is option C, 1.43 I plus 1. So just simply, Nana, you took the IC value, you just apply the N value. They have given the porosity. The porosity is going to be 30%. You simply substitute over here, then you will be ending with IC by 0.7 is going to be 1.43. So 1.43 plus 1. Now, you see this question. There is also previous one more question as a one more question, Anna. In a soil specimen, the total stress, effective stress, hydraulic gradient. See, this is the total stress, given total stress, and this is effective stress and hydraulic gradient. And IC, critical hydraulic gradient, is given. So they have given total stress, they have given effective stress as sigma C as they mentioned, and they have given hydraulic gradient, they have given the critical hydraulic gradient. For initiation of the quicksand, which one of the following is going to be true? You know that at a quicksand condition, effective stress is equals to 0 and critical hydraulic gradient I is equals to IC. Because factor of safety is equals to 1 R naught. So hydraulic gradient and IC both are same. So now you see what is this condition represents? You see this is not going to be 0. So effective stress cannot be 0. No. Effective stress is 0, and see, this is total stress given. They did not give us a effective stress. So this is total stress. Total stress is not 0. Effective stress is 0. Effective stress is 0 and I is equals to IC. Answer is C. No. Let's go for this next question. You observe this one. A volume of a mass, a unit volume. What is the meaning of a unit volume, Nana? Unit volume means volume is equals to 1 meter cube. Of a mass of a saturated soil is subjected to horizontal seepage. So this is a soil which is subjected to horizontal seepage. Horizontal seepage. This is a GATE 2012 2 marks question. This is a GATE 2012 2 marks question. This is 2 marks question, Nana. GATE 2 marks question. The saturated unit weight of the soil mass they have given. What is the saturated unit weight? 22 kilonewtons. and a hydraulic gradient, what is meant by hydraulic gradient? I as 0.3, then the resultant body force on the soil mass. So the resultant body force on the soil mass per unit volume. See, they have given a unit volume or not. Now, I hope you remember this concept. You know that always weight acts downward. So the submerged weight per unit volume is nothing but gamma dash, and you know that seepage force always along the direction of flow, which is going to be gamma W into I. So they're asking resultant force. So you know that resultant force per unit volume is equals to gamma dash square plus gamma W into I square. As volume is equals to 1, then what is the resultant force over here? The resultant force is equals to root of gamma dash. Did they mention any gamma value, gamma W value? No. When they don't mention in exam, if gamma W is not mentioned, always gamma W is going to be 9.81 kilonewton per meter cube. So now 22 minus 9.81 kilonewton plus 9.81 into I value 0.3 square. Then what is the resultant force, please? 9.81 into 0.3 square plus 22 minus 9.81 whole square root of answer, which is going to be okay, square plus 10 into 0.3 square. What is the answer over here? The resultant body force gamma W into I 9.81 into 0.3 whole square plus 22 minus 9.81 whole square root of answer, which is going to be 12.54 kilonewtons per meter cube, and the nearest option is going to be the 11.49. So the nearest value is going to be 11.49. Nearest value is 11.49 kilonewtons. So let me check once. Okay. Yes. So the nearest value is going to be 11.49. Yes. The actual answer is going to be 12.54, but the nearest value is going to be 11.49. From these options, the option is going to be C. There is no correct value over here, but the nearest value you have to take it as 11.49. So now that's about this question. See, these are 1 mark question and this is a 2 marks question, and there comes very good question. Next question. This question we have solved yesterday, right? And this is the question that I want to discuss now. Yeah, they might use the gamma W as a 10 also. See, and one more thing I want to say here over here is, for you, when you are writing an examination, if the question is going to be, you see here, you observe, and if question is MCQ, multiple choice question, then you can use gamma W as a 10 kilonewton per meter cube. If nothing is mentioned on gamma W, and if question is a MCQ, you can take gamma W as a 10. But if the question is numerical type, numerical type, you go for gamma W as 9.81 kilonewton per meter cube. Why, sir? Sir, if you take gamma W as 10, sir, you can get down the value, sir. That value is going to be nearest value over here. Yes or no? In MCQs, you have options. But in the case of the numerical type, as there is no options, there will be no options. So when there is no options, what will happen? When there is no options, then you must have to take the exact value. So always you prefer the gamma W as 9.81. In the case of ESE, for ESE, all the questions are the MCQs. For IES or ESE, engineering services people, all the questions are multiple choice questions. So you don't need to worry. Directly you can use gamma W as a 10. In this question, I can use gamma W as a 10 also. If you use gamma W as 10, you will be ending with 12.34. As I use gamma W 9.81, I got 12.57. But anyways, the nearest answer is going to be 11.49. So now, this question is one of the very good question. Now, just now I told you here, at a construction site, a contractor plans to make an excavation as shown in the figure. You see, there is a proposed excavation. So this is the proposed excavation. Now, this is the elevation of water, and this is a highly pervious sand, and this is a clay. See, just now I discussed with you what is a highly pervious sand and clay. Is it an artesian condition or not? Yes. The water level in the adjacent river is at an elevation of 20 meters, and the unit weight of water is a 10. The factor of safety up to 2 decimals against the sand boiling for the proposed excavation would be. See, they have given the unit weight gamma. Now, I told you here, sand is, you see, there is no other soil mass below. There is no other soil mass below. So sand is under artesian condition. So in the case of the artesian condition, you know that what is the factor of safety? Factor of safety means resisting by causing. Then resisting by causing means here total downward by total upward. So you see in the clay layer, the total upward is going to be artesian pressure, which is going to be gamma W into HA, and total downward is going to be total stress, which is going to be gamma into Z. So now everyone have a look. Please insert so this is a sand layer, right? In the case of sand layer, if you insert, now the water level will rise to the corresponding water table or not. So what is HA over here? What is HA? From 0 to this value, the HA is going to be 20. The HA is going to be 20. And what about the Z, sir? The Z is going to be this value, sir. What about this Z, sir? The Z is going to be how much, sir? Z is equals to 10. So now the factor of safety F is equals to gamma into Z by gamma W into HA. Keep this in mind. This is not a C phase. This is not a C phase. This is under artesian condition. This is under artesian condition. So in the case of artesian condition, you know that total upward is self weight of the soil. Sorry, downward is self weight of the soil. Total upward is just simply 4 watt means artesian pressure. What is the factor of safety? 20 into Z value as 10 by gamma W 10. They have taken the gamma W as 10 and HA as 20. Then the factor of safety is equals to 1. Then the factor of safety is equals to 1. See, you observe carefully. In the case of artesian condition, you see, in the case of artesian condition, this is not a C phase, Nana. Keep that in your mind. When there is an artesian condition, this is impermeable layer. So it won't allow the seepage that much easily. Then what happens over here is, this is upward pressure, right? This upward pressure will exert artesian pressure, and the downward is going to be gamma into Z. So what is the factor of safety? Gamma Z by gamma W into HE. But you see this case, this is an excavation well below the water table, and you have, I'm showing you the water levels over here. Yes or no? So that's about oh my God, I did not save this one. Okay, fine. I'll write once again over here. I saved. One minute. So see, sand is under artesian condition. Sand is under artesian condition. Did they mention it as a gamma or gamma sat? You observe here. Is it a gamma or gamma sat? Gamma. So the total downward force here is due to the excavation. Due to the excavation, you see, there is an artesian pressure which is going to be PA is equals to gamma W into HA. And you know, this is a soil mass of Z because he is going to be excavation or not. This is excavated. So the only soil is going to be left over this soil. And what is the unit weight of this soil? Gamma into Z. Because if you keep your palm at this base, the downward is going to be gamma Z. So factor of safety is equals to gamma Z by gamma W into HA. Total downward pressure by upward pressure 20 into, you see, what is this Z value given? The given Z value is 10 meters. If you want to go for, you can observe this one. And what about the artesian pressure? The meaning of artesian pressure is whatever the water due to this elevation, you observe here, from this the river water will enter into the pervious sand. So this is artesian head. The artesian head is equals to 20 meters elevation from 0 to this level. It is going to be 20. So 20 into 10 by 10 into 20, then the factor of safety is equals to 1. Some of the people are there more mainly focused on the breaks than answering this one. So elevation, yes, fine. Whatever it may be is okay. Is the elevation is not mm. This is in a meters. That's a typo. That's typo because they have given everything right. This is elevation 20 meters, na. So that's not mm. That's meters. Don't worry about that. How can I find it as an artesian head? See, you know that I told you if a permeable layer present between impermeable layers or if a sand is underlined by or overlain by clay, then then you are going to set as an artesian condition. So these are about the gate questions. And now, sir, why you don't take downward pressure submerged unit bed? अरे बाबा आपको दिमाग रहे भाई इधर कितने टाइम रे भाई? How many times I say? See, this is not a C phase. This is not a C phase. See, did they mention it as a gamma or gamma sat? Gamma. Then why I have taken this condition separately? If that is the case, then I would have said the same conditions, right? Why I take the condition number 3, condition number 2, and condition number 3 separately? This is a condition where there is an artesian condition. So when clay strata underlain by the sand strata, and this is a condition where there is an excavated below water table and made the excavation free of water. Those are two different conditions. Please understand that logic over here. Now, let's solve some of the classroom practice questions. Now, you please observe this question. Question number 1. Now, you understand this question? You see, this question number 1. An excavation is to be performed in a stratum of 9 meters thick, underlain by a bed of sand. Now the sand is under artesian pressure. So they mentioned it clearly, the sand is under artesian pressure. In a trial borehole into a sand. So what is the thickness of clay? 9 meters. In a trial borehole into the sand, the water is observed to rise an elevation 3 meters below the ground surface. So if you dig a trial borehole, the water level in that borehole shows 3 meters below the ground surface. The unit weight of the soil is 20. The depth to which the excavation can be safely carried out without the bottom becoming unstable under uplift pressure of water. The uplift pressure of water means artesian pressure. So what is the maximum depth of the excavation? What is the maximum depth of the excavation that we can solve? What is the maximum depth of the excavation that we can make sure that the bottom is not going to become unstable? I told you that for maximum condition or critical condition, just simply the downward is equals to upward. What is downward in artesian condition? Gamma into Z. What is upward in artesian condition? Gamma W into HE. If you please equate these two, you will get down the answer. Now, classroom practice question. Question number 1 and 2, both are same. Question number 1 and 2. Again, some of the people are asking, sir, there is a capillary raise. I said you clay does not have a capillary raise because it has low permeability. Though the capillarity is more, it takes very long time. We don't wait for that many years. Now, this is a ground level and there is a clay stratum. So, at some depth, it's a sand, and whatever this, there is nothing but 9 meters of the soil. Now, this sand is under artesian condition. They mentioned it clearly. The sand is under artesian condition. The total uplift or upward pressure is PA is equals to gamma W into HA. So further they mentioned that, so by inserting a piezometer over here on the top of the sand layer, it was observed the water level in this borehole rises up to a height which is 3 meters below the ground surface. So this is 3 meters below the ground surface. Then what is HA? You tell me, what is HA? This is 9, and if the water level rises 3 meters below the ground level, then HA is going to be 6 meters. Now, an excavation is proposed over here. Now, an excavation is going to be proposed over here. So, if you propose an excavation, let's say the depth of the excavation as Y and the remaining soil is going to be Z. So now whatever the downward pressure is gamma into Z. Here gamma is 20 kilonewton per meter cube. So now for bottom not becoming unstable, then effective stress is equals to 0. Then total stress is equals to pore water pressure. So you know that effective stress means total stress minus artesian pressure, because it is an artesian condition, right? So then total stress is equals to artesian pressure, which means total downward pressure is equals to total uplift or upward pressure. I'm using this condition because I'm not using, see, I don't want to directly rely on gamma dash into Z is equals to gamma W into H. I will go with the basic. The basic is the total stress is equals to, effective stress is 0. So effective stress is equals to total stress minus pore water pressure. Now, what is the total downward pressure? Gamma into Z is equals to gamma W into HA. Sir, somebody is asking why you are not using gamma dash. Arey Baba, if you use gamma dash, then H becomes HA. So there, the HA becomes H. Seepage head. Do you know the seepage head here? No. So now I want this Y. I want this Y. So can we write this as a gamma into D minus Y is equals to gamma W into HA. So what is gamma here? 20. And what is the total depth of the clay? 9 minus Y is equals to 10 into HA. So what is HA value here? The HA value is going to be 6. Then what is the Y value? 20, 6, 63. Y is equals to 6 meters. Can I say in other way? This is just the exact procedure, Nana. This is the procedure. And now I'll explain in a different way. Observe this one. If I explain in a different way, the different way means, you know that for no failure, the maximum upward should be is equals to the downward. Yes or no? Whenever the upward or uplift pressure is more than the downward, then definitely, I'll listen to this logic once again clearly. Whenever the upward is more than the downward, then there is a water, means the excavation becomes unstable. So for no failure or for not the excavation becomes unstable, the maximum upward pressure should be is equals to downward pressure. Yes or no? So now you tell me what is the maximum upward pressure, uplift pressure, gamma W into HE. You see the figure directly. I won't take not even 30 seconds to answer this one, because what is the maximum upward pressure? Gamma W into HA. What is that? Gamma W, 10. 10 into 6. How much it should be? 60. So the maximum upward should be 60. And for no failure, the maximum upward should be the downward. For no failure, upward should be downward. Array upward kitne 60, then downward should be 60. Yes, downward is going to be 60. When the downward is going to be 60, already gamma is 20, then gamma z is equals to 60 when the z is going to be 3 meters. When the z is going to be 3 meters, now the downward is 60, gamma into z is equals to 60, gamma 20, 20 into z is equals to 60, then what is the z value? 3, which means if 3 meters of soil is there, then fine, no failure. And out of 9 meters, if 3 meters are there, then how many meters you are going to excavate? 6 meters. So the logic is, for no failure, the upward should be equals to downward. Upward, artesian pressure, gamma W into HA, 10 into 6, 60. Then the downward should be 60. That 60 is going to be gamma into Z. What is gamma? 20. Then 20 into Z is equals to 60. Then Z is equals to 3. If the soil is going to be 3 meters present, then how much excavation is there? 6 meters. I hope you understood this. Now, you see the next question in that. It's not the end of the question. You observe here, in the above problem, if the excavation is to be safely carried of 7 meters, how much should the water table be lowered in the vicinity of the trench? See, I want to go for the 7 meters, then how much water table be lowered in the vicinity of the trench? You go for this one now. Let's see what is the minimum. What is the definition of the 6 meters over here? If you go beyond 6 meters, there is a quick condition. If you go beyond 6 meters, there is a quick condition. Yes or no? Now, they're asking, I want to go for 7 meters. All right, let's see. If you go for 7 meters of excavation, everybody have a look. If you go for 7 meters of excavation, then what is the Z value? 2. If it is going to be Z as a 2, then what is gamma into Z? 40. What is the downward? 40. What is upward? 60. Upward is more than the downward. Then the failure occurs or not? Now, I told you, in the case of the excavations, what are the preventive measures? By lowering the surrounding water level using the dewatering techniques. So now you see, in the same question number 2, for safe excavation up to y is equals to 7 meters, again the total stress should be is equals to artesian pressure. What is the total stress? Gamma into Z is equals to gamma W into HA. So gamma into 9 minus y is equals to gamma W into HA. What is gamma? 20 into 9 minus 7 is equals to 10 into HA. Then what is this HA? What is this HA, please? 20 into 2 by 10, which is going to be 4 meters. Now the answer is, if you want to go for 7 meters, see, look, in the question number 1, what they mentioned is, if the artesian head is 6 meters, then what is the maximum depth of excavation that you can go, which is going to be 6 meters. But you come to me, sir, I want to go for 7 meters, sir. Then I immediately say, Are Baba, 6 meters is the maximum depth. You cannot go for the 7 meters. If you want to go for the 7 meters, you have to lower the surrounding water table, which means the water level in the borehole should lower. Now you ask me immediately, Are sir, I say, okay, fine, sir, I'll go for the 7 meters, sir. Then how many meters you are going to lower it, sir? Now you see, sir, if I want to go for the down with the safe, the downward, what is the downward now? So 7 meters gone, then the Z should be 2 meters. Then 20 into 2, the downward should be 40. The downward should be 40. Then maximum upward should be 40. When does the PA is going to be 40? If I say 40, then gamma W 10 into HA is going to be 40. Then what is HA value? 4 meters. What is initial? 6 meters. And if I go for 7 meters, what is HA? 4 meters. So now I can say initially 6 meters, finally 4 meters. Initially 6 meters, finally 4 meters, which means the change in head is going to be 6 minus 4, which is going to be 2 meters lowered. So in order to go for excavation of 7 meters, water table should be lowered by 2 meters. That is the answer. So actually we don't need to take this much of time for this, but we have taken so that I can make sure you can understand everything. The logic is the logic for no failure. Upward is equals to downward. That's it. If you understand this logic, you can answer any type of questions I'm telling you. You can go anywhere and you can find out those are. For no failure, upward is equals to downward, or downward is equals to upward. And if you want a basic, this is going to be the basic I mentioned. This is the basic I mentioned. So that's all about this question number 1, and we'll be solving the remaining questions after the break. So let's have a break. Let's have a break. It's 11:26. Now you have a break, and let's gather at 11:45. So you please have a break. Come on, 11:45. Hi again, everybody. The Zoom section has been redirected. So now I'm asking you, some of the students, I hope my voice is clearly audible to all of you and my video is also clear. So one thing I'm asking you people is, see, I missed the whiteboard again. I actually saved it, but it did not saved. So whatever the whiteboard, if you have taken the screenshots of the whiteboard, or if you have recorded the screenshot of the whiteboard, please send it to my mail ID. Please send it to my mail ID. So the people who have, please respond to this message. So the people who have already taken a screenshots of the slides I have explained earlier, please send me the screenshots, not your handwritten notes. Please send me the screenshots to my mail ID of the previous session. So please send me that white slides. I hope my voice is clearly audible and visible to all of you. Please respond to this question. Please send me that as soon as possible. Okay. Okay, fine. So now before going to the next session, next questions. If anybody have taken that screenshots, please send it as a PDF for me. Okay. So now, before going to the next questions, I want to share something regarding to the GATE. So the preparation that I have done and the way that I went and how you need to go to the preparation strategy and whatever the mistakes I have done while I was doing my preparation and whatever the things that you can take care of yourself not to fall into the pitfalls. So listen first. Actually, every year we see the GATE pattern, but the problem with the GATE pattern is if you look over from 2014 to 2019 or 2020, last means this year, whatever the GATE paper that has appeared. So the level, the pattern level is not too difficult or not too easy. So the pattern level is going to be a medium level. I told you in the earlier classes, an examination pattern should be always in such a way, out of that 100 marks, 33% of the marks is for the easiest marks, 33% is a medium, and 33% is a hard level. So which means any person who takes coaching and who attends the lectures, who's practiced some questions, they can easily attain 60 to 67 marks. And the persons who apply more logics, who works hard work, and who makes their work as a smart work, they can get the marks more than 70. So then what is the meaning of here hard work and smart work? See, everybody think that one of our students is also asking, sir, how do we cope with the IITs? See, I am not an IIT and I have studied in a SV University. See, compared to some other college universities, SV University is better. But there are some students or there are some friends of mine who studied in normal colleges and who attained very good GATE rank also. One of my friend is there. So he has done his structures in IIT Hyderabad only. And his GATE rank was 250. And you know, he studied in RVRJC College, Guntur RVRJC College. And I have studied in SV University. My GATE rank is a 621. And with a GATE score of 770. So the point over here is, it's not about IIT, and there are some people who are IITians, they did not qualify to the GATE also. So it's not about IIT or some university or some private college. It's about you. How to approach the procedure. So now let me tell you that means the journey that I have been for, so I don't take much time. I told you I was a student of the same AC Engineering Academy, but I have taken the short-term crash course, which means, so at the end of the third year and before the final year, there was a 2 months of, after semester. So third year end semester, you will get 2 months of holidays. So in Hyderabad, there is a special batch which extends from 50 days to 60 days. That is a crash course coaching. So it is exactly not more than 60 or 65 days maximum, within 60 to 65 days. So it will be completed. I have taken a coaching in 2012, around I think so March, April ending, April 25th or so, May, June, and by June ending, my coaching has been completed, which means up to June, I was in the sessions only. And you know what? The classes were conducted from morning 6:30 a.m. to evening 8:30 a.m. Sorry, 8:30 p.m. Which means I did not got a time. See, the entire 60 days, it was about going to the class, listening to the class, and writing the notes in the class. So I was completely fulfilled. Means I did not miss any class. So I mean, probably I missed the English classes. You know it very well. Though how many times you go for the English class, we know our English. So definitely I know that. So I skip some English classes and I skip some boring classes. But majority, I attended all the classes. I have written the notes, and you know what? While in the classroom, while the faculties were teaching, I thought it was a very fascinated. I understood it very, very clearly, and I used to solve the questions before the faculty used to solve. So when he projects that question, I'm giving some 2 minutes of time. As he said, I definitely complete that question within 2 to 3 minutes. And I used to say the answers in the class itself also. So I thought of like I was understanding the subject very clear. So it went on, and I have completed all the subjects. And by the end of the June, so my final year has been started. So in June 20th or somehow my final year has been started. So once I went to the final year in my university, I just stopped the studying these GATE subjects, because in the final year, and that too, we know that in first semester within 1 month they will give the internals examination. So from May, and in May and June I have taken a coaching, and June ending I went to the college. So in June ending and July entire I was attending the academics final year first semester, and I kept all the notes of my GATE notes aside. I kept it aside. I did not open for the next 1 month completely. And in August, after July, August 2012, August, there was an internal examination. So I still remember, by August 15th, means August 14th, my internal examinations has been completed. So then I started, okay, I thought of like, I give the internal examinations first, then I start the preparation, which means I did not start the actual preparation up to August 15th. And keep that in your mind, 2013 February 9th was the examination of GATE. And I did not start the actual preparation by August also. So by August 15th, I started the preparing. Now, you know what? After opening the notes, what I have written 1.5 months back, I just seemed myself, have I written these notes? And is it me that I have explained all these concepts? Is it me I have solved? While the classes were going on, what I used to do is I used to write my own logics over there. And I used to write small points. Even the faculty says that total points, I used to cut short it, and I used to write in a small manner. I don't write the total lengthy sentences. I do it as bullet points. But that made me to cost like anything once I started the preparation. See, while the classes are going on, the people think we get everything. Yes, even me. While the classes are going on, I understood exact 70 to 80% of subject I understood. But the mistake I have done is, after the class end, I did not got a time. Morning 6:30 a.m. to 8:30 p.m. You can imagine. So the total 14 to 15 hours we were there in the classrooms. And after 8:30 p.m. you don't get enough energy. You will become tired, because the next day you have to go early. So I used to solve the questions in the classroom, and I completed all the classroom practice questions. But the problem is, when I started in August 15, means after August 15, when I start to see my own notes, I felt like it was new. I felt like it was a Xerox of somebody. I felt like it was just a notebook that I have borrowed from my friend, because I didn't remember anything at all. I did not review, and I did not revised. I kept all the notes aside. Then I started my preparing. See, my starting preparation was done in August 15th. I still remember that in August 15th, I started the preparation. And in the first stage of preparation, while you're preparing, there are some stages. Stage number 1, everybody do this mistake. See, the first point is most of the people, I want to go for the gate. I want to go for the gate means I want to give a gate and I want to get very good gate rank and I want to enter into prestigious institutes, IITs, and I want to go for PSUs or I want to crack any government service examination. With that energy and with that fire in you, initial days, what you do is you study a number of hours. On August 15th, I started and I read around 9 hours in a day on the day itself. I read 9 hours in the same day. And in the next day also I read 10 hours. And in the next day also I read 10 hours. And after 3 days, I fell asleep. And I did not study the next 3 days. So what I have done is, up to August 15th, I did not study anything. Means I have taken a break of 1.5 months. And immediately on August 15th, I started reading. And immediately on August 14th, 0 hours of study. August 15th, 10 hours of study. So 3 days, 9, 10, 10. Continuously, my body did not cope up with that time I'm spending for the study. Because that's a new thing. So first thing, my dear students over here is train your brain. And try to make sure your brain and your body should act according to each other. See, no act is going to be a pro without one single perspection of act. By doing one time, you are not going to become a pro. You have to increase the level of intensity. So the first suggestion I'm giving you is, when you are preparing, make sure your body and your mind should coordinate. Sir, how to make sure your body and mind is going to be coordinated, sir? For that, you make sure every day a specific time. I hope some of the people might study late hours. Some of the people may have interest early in the morning. Some of the people after breakfast. Some of the people after lunch. There are 24 hours of everyone. But the way that you are going to prepare is going to be entirely different. So I'm leaving this question for you. You pick your own timing. From today onwards, or from the day of preparation onwards, you pick your timing. And let's take only 1.5 hours per day. Or let's take 2 hours. So let's take 2 hours per day. So you start 2 hours. Whether it may be morning 5 to 7, or 4 to 6, or late night 10 to 12, or 12 to 2, or 2 to 4. You take any time, whichever the time is possible for you. Do not make any excuse and make sure you allocate 2 hours of your time. And in the 2 hours, you must have to study. No mobile, no TV, no social media, nothing else. Just until or unless you get small doubt, then only you check means by means of dictionary or by means of YouTube videos. But as long as you have the classroom notes, and right now the online sessions are there, because of that you must have to go through the PDFs. So even if you use mobile phones or your laptops, make sure yourself strict for the social media apps. They will distract you like anything, Instagram, Snapchat, and all those things. Those days while I was studying, so in 2012, I did not have the proper mobile also. I have basic mobile. So those days it was very easy because I did not get distracted with this Facebook or WhatsApp. But right now, we have a lot of distractions. So please make sure yourself away from these distractions. Number one, body and mind coordination. For that, what to do, sir? 2 hours per day. 2 hours per day. So then, what I do, sir? For the next 1 week, you read 2 hours a day. So let's say, see, I am a night owl. Which I mean, I used to study more on nights and rather than the days. So generally, I mean, whenever everybody is able to sleep after 10 o'clock, I used to start my reading. So that's the time I prefer mostly, but you can prefer in whatever the time you want. So let's say some evening, or let's say evening some 5 to 7 o'clock. That is a slot you made. Every day, without any fail, for the next 7 days, you please make sure you try to concentrate on the subject for the 5 p.m. to 7 p.m. It's not about studying, it's about allowing your mind and your body to be gets coordinated. See, your body has to be habituated with the thing you are going to do. See, from our childhood onwards, we are eating morning, afternoon, and night. Nobody says, in childhood, our mother says that you have to eat at this time, Nana. You have to eat morning, afternoon, and night. But now, once you are grown up, nobody says that you have to eat this time. So, but by the time you reach 1 p.m. or 2 p.m., no matter whether you are hungry or not, you try to eat something. Well, by the time you reach 8 p.m., no matter your hunger or not, you try to eat something, which means your body cycle has been habituated to that. Can you eat a dinner at 5 p.m.? Can you eat the breakfast at 5 a.m.? No. Our body has been habituated over a period of time. The same thing with the studies also. And the time you are going to mention, it should be allocated and it should be habituated. So the first mistake that I have done is, in earlier days, I used to read rigorously or vigorously. So 10 hours per day. After 3 days, I fell sick. And in the next 3 days, I did not study anything, which means for 6 days, I studied 30 hours on an average of per day 5 hours. If I would have started for the 5 hours every day on the 6 days, 5 hours each, my preparation would be effective. But now you see, I spent 6 days and I studied 30 hours, my effectiveness is going to be 0. So that first mistake I have done. And after that, I started studying, means I make a mic should allocated. So how, sir? Once my college, and this is a tip for every college student over here. So my college usually ends at 4:30, and I used to go play some shuttle or some running or whatever it may be. I used to spend some time with my friends and all those things. So I used to spend up to 5:30 or 6 o'clock. By any cost, I used to come to 6 o'clock to my room, and I feel a little bit fresh by 45 or by 6 o'clock. I used to start, and in that 6 o'clock, 6 to 8 was my preparation time. In the final year, 6 p.m. to 8 p.m. was my preparation time. And after 8 o'clock, I used to go for the dinner. So I make sure these 2 hours every day without any fail. So no matter what, after the college and after I spend some time with my friends and with my sports, so I go to the studies and I start the studies at 6 o'clock and I complete up to 8 p.m. Which means I made myself to habituate to the time. And later on, I reduced the time to going out. And then after 4:30, I started at 5 o'clock of preparation and 8 to 8:30 because my mess timings was up to 9:30. So I used to study from 5 to 8:30. Meanwhile, in between, I used to take 10 to 15 minutes of break. And then after 8:30, after some days, I go to the lunch, I go to dinner at 8:30 and I come back and I take some rest and I used to start to read again at 9:30 p.m. So 9:30 p.m. to 11 p.m. So now my timings has been increased from 5 to 11 p.m. and then 5 to 12 p.m. And then sometimes I used to wake up in the classes also. In the class also, what I do is mostly in the final year sessions, we know that almost all the technical subjects we used to cover in third year only. So in final year, some subjects would be there which of no use. So what I do is I take a white paper. Step 2. Step 1 is habituate yourself to the timings. Step 2, whenever you get a time, I use this tip especially in the classes. I used to sit on a back bench. I was not a front bencher, I was a back bench student only. So I used to sit on the back bench and what I do is, if the class is boring to me, I do take a white papers or I do take a notebook and I start writing the formulas like anything. I don't keep any pattern. Why? Because the step number 2 and the preparation strategy is, in the examination, your paper is going to be a zigzag pattern. Out of 65 questions, first question may be maths, second question may be aptitude, third question may be geotech, fourth question may be hydrology, fifth question may be structures, sixth question may be CPM and Perth. See, these 6 questions are there. You are going to try to solve all the questions at a time. And your brain has to swap from one subject to other subject within no time. For example, you are solving a geotech question and immediately after geotech, you are going to solve a structures question. There is no relation between the geotech and structure. And immediately you have to think about structures. Okay, which formula it is, how I have to apply this one, whether I get the answer or not. So it's like a warrior practicing for the war. You are not going to be entering into war directly by taking a sword or a shield. You have to practice. The practice means make sure yourself in a zigzag pattern. For that, the tip I followed is I take a white paper and whatever the formulas that comes in my mind. For example, geotech, Q equals to KIA. Next, I go for the environmental. In the environmental, what is it related? Settling velocity, Vs equals to G by 18 into S minus 1 into D square by mu. And then I go for the hydrology. In the case of hydrology, what is the infiltration capacity? I go for the structural analysis. How to find out the DKI or DSI? I go for the RCC. How to determine the yield stress of the steel, which means I made myself to think in a different manner. That's a zigzag pattern. So strategy number 2 is take a white paper and do practice the equations continuously. And while you are writing the equations now, make sure if Q equals to KIA, what is K? Permeability. What is I? Hydraulic gradient. Then immediately what you do is, okay, hydraulic gradient. So how to find out hydraulic gradient? Head loss per unit length or hydraulic head per unit length. What is hydraulic head? Difference between the water levels. So where to use the I value? Wherever I want to find out the pressure head, I can use the I value. So how to find out the stresses? See, with the one formula of Q is equals to KIA, I am going to look over wherever the applications I have done and how I have find out what is the significance of I, what is the significance of K, how to determine the Q. All these things, one formula, I'm going to revolve all the concepts. So strategy number 2. Yes. So now strategy number 3. The strategy number 3 is wherever you go, whether you do bath. So don't take in a wrong way. Whether you do bath, whether you go for toilet, whether you walk, whether you run, whatever the time you're going to spending, or whether you're going to travel into some place, what I do is I keep the headset in my ears so that no noise would be there. I mean, if I go outside, so what I do is I memorize the equations. I memorize the equations continuously. I memorize the equation. Wherever the break gives, I memorize the equations. Wherever I go out, I memorize the equations. During the sports also, whenever the time completes, I memorize the equations. Every day, the task is whatever the discussion I have studied, I used to remember the formulas. Even before sleeping also, I used to memorize all the equations. Memorize. Third thing, this is the stage 1. Tips are 3 tips. Number 1, make sure yourself habituate with the timings. Number 2, wherever you get a time, try to write down the formulas. Number 3, memorize the equations and memorize the formulas. This is a stage 1 of your preparation and how to make sure whether you are habituating the competitive examinations or not. Now there comes the stage 2. So stage 2 is what we have to do. So I'll write down those things also. Preparation. In stage 1, body and mind coordination. So time schedule and memory or memorize or writing down formula. Now there come the stage 2. So in the stage 2, most of the people, what they do mistakes is, by the end of the stage 1, by the time you are going to habituate with your body and memorize, you might have been completed one subject. For example, let's say our geotech has been completed and you have started the geotech and you took some 10 days or 15 days of your time. You read it completely. You solved all the previous gate questions and you solved all the previous IS questions and you solved everything. So now you are going to start the second chapter. Most of the students, you are going to make a wrong here. Now where I have done also. Now what I have done. So let's say what I have done. I told you I have started on August 15th. Then I took August, September, October. I finished all the subjects within 2 months, 2.5 months. I finished all the subjects with 2.5 months. I took some 10 days for every subject. So 10 days, so 2 months, 60 days. And whatever the small subjects like open channel flow, irrigation, hydrology, I used to complete it within 2 to 3 days because I have already solved it a good way. So now I used to spend for the major subjects, I take more time, and for the minor subjects, I take less time. So what I did is, first I completed geotech, then I went for the environmental, then I went for the transportation, then I went for the strength of materials, then I went for the all other things. So what happened over there is I completed all the subjects within 20 means 2.5 months. And that's the biggest mistake that I have done again. What happened over here, sir? After 2 months, again I started revision. When I started revision, what happened is the first subject that I completed is geotech. And geotech was fascinating and it was very interesting to me in those days. That is the reason why I took geotech as my main subject. So what happened is after 2 months, when I started revision the geotech, again I felt the same way how I have started my first preparation, which means I read the subject, I completed the subject, but I did not revise. So second problem and mistake that every student makes sure is once you complete the subject, one subject, do not leave that subject. Do not leave that subject. Do try to revise that subject as soon as possible. Now, you may ask me, Are sir, if I try to go for revision, then again, I have to go for the same notes. The notes may consist of some 250 to 300 papers, and it will take a lot of time for me revision, and I cannot focus on the next subject. There comes my second stage 2. After you complete one subject, after completion of one subject, let's say geotech, let's say geotech. So geotech has how many chapters? 20 chapters. Now, assess yourself. How to assess, sir? What you do is you take A4 sheets. This step, you people, please follow this one. This is going to be more effective because right now in stage 2, it is going to be hard work and stage 3 is going to be the smart work. How, sir? Let's say I'm there and I have taken 15 days of my time and I have completed all the geotech subject and I have completed the 20 chapters. Now I need to assess myself. What is the assessment, sir? You take a A4 sheet. So let me show you. Okay, fine. You take any A4 sheet. You take, yes. Let's say, see, this is going to be some A4 sheet. You take any A4 sheet and you make sure one sheet for one chapter. You make sure one sheet for one chapter. This is a paper, right? This is a paper. You divide this paper into 4 portions, which means one side 2 portions. You make it as a half. One side 2 portions. Other side 2 portions. So for this A4 paper, you can get 4 portions. Yes. So what you need to do over here is, in geotech, there are 20 chapters. I take 20 papers. I take 20 papers, 20 set of A4 sheets. So now what I do is, on the front side, I keep the notebook, I keep the material, I keep the textbook aside. So what I do is, in the first chapter, let's say chapter number 1, origin of soils. In origin of soils, whatever the points I have been remembered, whatever the points I remember, whether you remember 30%, 50%, 80%, 90%, whatever it may be, you write it on the white paper, which means A4 sheet. So this is an A4 sheet. On one side, you write whatever the points you remember, chapter number 1. And similarly, you take one more sheet, chapter number 2, one more sheet, chapter number 3. Likewise, 20 chapters are there. You have to write the major important formulas and note points. See, while we discuss a lot of things, but in reality, the note points would be very, very less, right? So now you have to make sure yourself a short notes. So basically, my geotech notes would be around 250 to 200 pages, 300 pages, Nana. Again, okay. Again, everything gone. Okay, fine. So if there is any important point you're missing, then you please note it on the back side with a different ink. So second stage is making sure a short notes. How to prepare the short notes? I'm going to attach a PDF of mine, how I have prepared. So that file is still with me. I have written it long back. So I have made a lot of modifications during the lectures also. So I'll be sharing my short notes of geotech to you at the end of the, means today by evening, I'll be sharing the PDF also. I made the entire geotech into 13 papers. These right? 13 papers, 3 papers. That was the short notes I made. So what you need to do is you take a paper, stage 2. Once you complete the subject, you take 1 or 2 days to prepare the short notes. You take 1 or 2 days, you prepare the short notes. How to prepare the short notes? 1 chapter, 1 paper. 20 chapters, 20 papers. So in the entire 20 papers, there is a short notes. Now you start the next subject. Again, by this time you have coordinated with the body and mind. You have been habituated and you have completed one subject and you have already made a 1 chapter, means a 1 subject short notes. Now second chapter, environmental engineering. Let's say you are studying 6 hours per day. Let's say you are studying 6 hours per day. Now make sure you take, for example, in 6 hours as a 2 sessions, 3 hours and 3 hours. You start the environmental engineering. For the first 2.5 hours, you study the environmental engineering. For the first 2.5 hours, you study the environmental engineering. Then you take a 30-minute session for the previous. What is the previous one? Geotech. And already you have short notes, right? Now you try to revise that short notes, because as you have 20 papers, how much time it takes for you to revise? So every day 6 hours, means you have habituated every day 6 hours. So let's say 2.5 hours for environmental, next 30 minutes geotech. Next 2.5 hours for the environmental, next 30 minutes the environment, next 30 minutes geotech. So let's say by the time of next 20 days or 10 days, environmental will be completed, and along with the environmental, you have completely revised the geotech. And now after the environmental, you take 1 or 2 days gap again. In environmental, around 18 chapters were there. So again, you make sure a short notes, 18 papers. See, it will take a lot of time. I know that it will take a lot of time. That's the reason why I say in stage 2, there is a hard work. So in this hard work, once you complete the subject, if you make sure the entire short notes, there are around 15 subjects for you. There are around 15 subjects for you. And hardly if you can prepare, see, for geotech and environmental, it may be 20 papers. And for remaining subjects, it's going to be very less number of papers it requires. For open channel flow, 4 to 5 papers. Irrigation, 3 to 4 papers. And hydrology, 5 to 6 papers, which means I'm telling you, means the number of papers would be less. At the end of your preparation, stage 1, after your entire preparation, you are going to end up with a short notes, which is equivalent to some 300 to 400 papers. Your entire civil engineering subjects, you reduced a short notes of around 300 papers. 300 papers means whatever the notebook you are carrying. I hope you are carrying some notes with you now. That notes consists of around 250 to 300 papers. So in the first stage of preparation, it may take more than 3 months also, or it may take more than 2 to 3 months. But in the case of a stage 2, you prepare the short notes along you complete the subject. When you start the subject number 3, already you have subject number 1 and subject number 2 short notes. Every day you study subject number 3, you spend 1 hour for revising 1 and 2 subjects. And similarly, subject number 3 completed, you prepare the short notes for the subject number 3. Subject number 4 coming. So by this time, as you increase your time to prepare, now it is going to be increased to 6 to 7 hours, 6 to 8 hours, 6 to 9 hours. My effective preparation has started October end, because what I have done in August 15th to October is only reading, studying. I did not make sure a short notes. That was the problem, that was the mistake I have done. So once I started reading the second revision, I made it as a second, I made it as again a problem for me. Then in the second time I was revising, I make a short notes. When I make a short notes, then it affected me in such a way that it took very, very less time from second revision to third revision, and much lesser time from third revision to fourth revision, and very less time for fourth revision to fifth revision. At the end of your revisions, you will be end up with the 300 papers that you can revise completely 10 per day, 10 papers per day, 10 papers, right? You can revise it. This is a stage number 2, and stage number 3 is revisions. Stage number 3 is going to be revision. The revision is going to be smarter. So the strategy that I want to share with you is number 1, time coordination. Number 2, memory. Number 3, make a short notes and revise along with the other subjects. Number 4, the most important one is schedule. How to make sure your schedule. How to prepare the schedule. So now, schedule. See, everyone, without a plan, you cannot win a war. Though you are a good warrior, though you have a very good school, very good skills, without a plan or without a strategy, you cannot win the war. The same way here also the schedule. See, I will divide the subjects in such a way as the major subjects and the minor subjects. This is the way that I have made also. In my room, while I was preparing, I took a big chart. Once, whatever the drawing charts would be there or not. In the drawing chart, I made a total schedule that I am going to do for the next 3 to 4 months. Every day, what is the subject I am going to read? So the schedule is, so as I told you, the major subjects. The major subjects, geotech, environmental, strength of materials, transportation engineering. And fluid mechanics part 1. These are the major subjects, and the next important minor subjects are RCC, hydrology, surveying, and open channel flow irrigation. OCF means open channel flow irrigation. So apart from this, some of the structures other subjects are going to be like so others, steel structures, structural analysis, CPM on Perth, and any other subject, structural analysis completed, CPM on Perth, and engineering mechanics. See, these are some other subjects. See, these are I kept as others. See, I give the weightage in such a way that these are the major subjects, these are the minor subjects, and these are the others. What I do is I prefer the order. When you make a schedule, you make sure in such a way that in the next 3 months, what you need to prepare. So you have to make a schedule. Sir, I started geotech, sir, I will read upon, sir, I will read up to the last point, sir. No. When you start geotech, make sure you are taking 10 to 15 days. So now, for example, let's say you start your preparation on August. Preparation from August. Let's say that in August 1 to 15, which means 15 days. I'll start one major subject and I'll start one minor subject. The one minor subject is going to be open channel flow. Because geotech is going to be bigger subject, open channel flow is a smaller subject. So I will start two subjects. So more time for the geotech, less time for the open channel flow. Within 15 days, you have to complete this one. And take a break of 1 day. Next, August 17 to 30th, 31st, June, July, August, 30th. Yes. So next 14 to 15 days, what I do is I take environmental, and out of these, little bit easier is going to be hydrology, because environmental and hydrology both are represents water resources. So there is some similarities that you are going to see over here. So now what I do is next environmental, hydrology, along with revision of previous. See, by the end of the August, what I have done is within 1 month, in a 30 days, I studied two major subjects, geotech, environmental, and I studied two minor subjects, open channel flow and hydrology. And take a break, prepare short notes. Take a break and prepare short notes. So minimal, same way, August, September, again from September to let's say 15th of the September. See, I am taking some arbitrary values. I'm taking let's take 15 days for two subjects so that I can complete a major and minor subject. Now let's go with the transportation engineering, and I go with the RCC, because transportation engineering the number of chapters are less, and RCC 8 chapters are there. So now I go with the transportation engineering. And I go with the RCC. Next, take a break. Next, NUM 16 to 17 to 31st. Similarly, now I go for the FM1 and I go for the irrigation okay, fine, irrigation. Next, October 2nd to again 15th. So now you go for the strength of materials, and surveying. See, let's say I increase the time over here 2 to 20. September 22nd to October 10th, revision of all. And next, October 12 to 31st. See, I'm increasing the time also. At first I took some 14 or 15 days, then I am increasing directly to some 18 to 20 days. Why I'm increasing over here is, if you observe clearly, by the point of this one, how many subjects you have completed? Geotech, open channel, environmental, hydrology, transportation, RCC. So now you have to revise all those subjects. So already you have been revised geotech with 5 times. And you have revised the open channel flow 5 times, environmental 3 times, hydrology 3 times, transportation 1 time, RCC 1 time. So now in the August, October, now August, September, October, now November, in the case of the November 2 to again 20. See, by this time I completed all the major subjects you observe except irrigation. Now I go for this one, structure analysis and irrigation and CPM per. Analysis, irrigation and CPM per. Next, November 22 to December 1st. That's that end of your preparing the remaining subjects, steel structures and engineering mechanics. Engineering mechanics. This is one way of preparing. Let's take once you complete this up to transportation, let's you say you take a break over here. Take a break over here. Take a break for 15 days. Test series. Complete the test series for the, see, in the case of test series, we are going to provide around 72 subjects, okay? 72 tests. There are subject-wise test series would be there, and mixed test series would be there, and a grand test would be there. So if you want to prepare for this one, so I will say that you please go for this one, and you take a break of 15 days. You take a break of 15 days and you prepare for the test series. See, mind it, every day you have to go with this one and make sure yourself keep some time for the test series. And from the day 1 to day end, increase the number of hours, 2 hours per day, 2, 3 hours, 4 hours, 5 hours, 6 hours, 7 hours. I'm telling you, by the time I reached the December, I don't know how many hours I have studied also. Seriously, I don't know how many hours I have studied. Because while I was in the class, I studied. While I was in the break, I studied. While I was in the evening session, I studied. At night session, I studied. Early in the morning, I studied. I did not count a time. If you count a time, then it will make you to feel weird. And it will make you to feel tired. And it will make you to feel pride also. Because you might feel that I'm studying 10 hours or 12 hours. Do not count your time once your body has been habituated with the studying. So, and similarly, after this one, take a break. Test series. Now, the last mistake I want to say. See, I just give this an overall. It's up to you, Nana. Means if you are starting the July only, then the preparation strategy would be different. If you go for the August, September, the preparation strategy would be different. But make sure you prepare a well planned, because you know yourself how much time it will take. Just because I read 15 days, somebody may complete the subject within 10 days. Some may take 20 days. Some may take 5 days. So it's up to you. I'm not going to say which day is going to be really example. Means I'm not giving you as a, this is a fixed plan, but you make sure a plan for us, means for you people. And what about aptitude and maths, sir? Aptitude and mathematics should be there. That's what I'm going to say. Next stage. So stage 4, maths and aptitude. Maths should study one chapter per day along with technical subjects. Half chapter a day, 0.5 chapter a day along with the technical subjects. For example, I studied geotech. In the mathematics, matters are there. See, continuously if you study one subject, you will get boring. So I start mathematics and I go with the matrix. Matrix, I study half a chapter a day. Half a chapter a day. Hardly there are 7 to 8 chapters in the mathematics, half a chapter a day. So I know the chapters and I can go for that. Mathematics should be starting to ending continuously have to study. So far I discussed the technical subjects, and now the mathematics is mathematics should be included every day. It should be present every day. Now, stage 5. Stage 5. The last stage. Practice, practice, practice. By time you reach December, you should complete all the stage 4s. Stage 1 to stage 4 should complete. See, you have classroom practice questions with you. You have volume 2 as self-practice questions for you. You have previous GATE questions for you. You have previous ESE questions for you, and you have test series for you. Now, the major is, see, 70% or 60% you are prepared, and remaining 40% is going to be time management in the examination. Now, once you start the test series, most of the people may get a D grade. See, every year, I mean, I was in a teaching field from the 4+ years, and every year, by the time that December or January reaches, I get a mails and messages from my students. Sir, I am getting discouraged because I am not getting good marks in the test series. I have read everything clearly, but I am not able to crack the answers. Hota hai. Everybody goes through that. I'm telling you, everyone goes through that, even me also. See, even means as a faculty, I'm teaching the same subject for 4 years. If you bring me a new question to me, I will think about that. I'll take some time to answer that question. Okay. So you are going to write the examination. Definitely you are going to do mistakes. And the mistakes that you are going to do, you see, those are not the mistakes that you don't know. Those are the mistakes that you know very well. And I say one mistake. In 2012, in GATE paper, means 2012-13, while I was preparing, means I have given examination. There was one more question. See that question. A fully saturated soil mass, this is the question, a fully saturated soil mass has a water content of 30% with a specific gravity 2.7. A fully saturated specimen has a water content of 30% with a specific gravity 2.7. The porosity of the soil sample is. They have given options. See, everybody, those who knows this one, arrays are fully saturated, yes are 100%, water content, specific gravity, hey, then I can use Sehwag, then I can find out the void ratio, and I can find out the porosity. This is the very simplest formula, right? The mistake that I have done is, I use Sehwag, and I got the E-value, and there is an answer of the E-value also. I did not see the question properly. I did not saw its porosity. I thought of it as a void ratio, and I kept the answer of void ratio. That's how silly it is. I know the basic mistakes. Number 1, units. Number 2, conversions. Let's say conversions and units both are same. And number 3, range of answers. Range of answers. Number 4, improper understanding of questions. See, these things you may not know, you may not know now, but once you start the test series, you're going to see all these things. So units conversion, range of answers, improper understanding of questions made you to fall into negative zones. But don't get discouraged. The first test I got is a -3.67. That's a subjective-wise test, a 25 marks test, but I got -3.67. That is the first test I got. And see, nobody can make sure 0 error. If that is the case, the first rank holder, GATE rank holder should get 100 marks, but he is not getting 100 marks, right? If he is able to cracking 85 to 90 marks, then he can able to crack 10 marks also, but he made some mistakes. And due to that mistakes, he lost some negative marks. So the last step is practice test series so that you can reduce the errors. You can reduce the errors. So the errors are going to be not 0. At first test, you made 10 errors. You go for 8 errors next, 4 errors, 3 errors, 2 errors. The percentage of errors should be decreasing with respect to the tests. That is the biggest mistake that I have done. I did not solve many papers because as I started effectively my preparation August, September, October ending. So I have left it with some November, December and January only. I prepared only 2 to 3 months. But I revised the subjects like anything, but I started the test series on January 5th, 2013. I started the test series. My examination was on February 9. And it was too late by the time I started the test series 2013. So I went in such a way that, you know what, in examination, due to this mistake, the depth I paid is out of 65 questions, I attempted 55 questions due to lack of time. I did not see 10 questions. I did not saw the 10 questions. I didn't saw the 10 questions. I ended with my marks as 65.63 marks. This is my marks, and I got All India rank as 621. My marks is 65.63 and my rank is 621. I missed how many questions? 10 questions I missed. I did not even got a chance to see those questions here. And after the examination and for the next 1 year, it haunted me like anything. If I would have seen at least 3 to 4 questions, or if I would have seen 5 questions, or if I would have get 70 marks, means if I would have get 70 marks, my friend who has done IIT structures, his rank is 159. You see, from 65 to 70 marks, the range has changed from 600 to 159. The 3 hours of your examination time will make your future next. The mistake, the biggest mistake that I have done is I did not practice. I know the concept. I study the concept. I know how to solve, but the practice makes the time. So the more you practice the questions, the lesser the time it takes to solve those. And with that, I was back of 10 questions. And it was a question that in my back of my mind, if I would have solved at least 2 to 3 questions, or if I would have gone for 5 questions, if I would have got more than 70 marks, I would have joined in a PSU, public sector units. I would have earned more. If I would have a very good gate rank, I would have gone for the IIT Bombay or IIT Delhi. I can go for the structures. Else I ended with the IIT Hyderabad. I know I love geotech, but apart from that, I can go for the bigger IIT than the IIT Hyderabad. See that mistake. Your 6 to 7 months of your preparation is for just 3 hours of your what time, and that 3 hours is going to be decide the rest of your future. So make sure yourself. I told you 5 stages: habituation, mind coordination, memory, short notes making, revision of the short notes every day, revision, revise, and 4th one, include the mathematics and schedule, make a planned schedule, 4th one, and 5th one, test series, practice. These are the things. You start in a harder way, and over the period of time, your hard work will remain as a smart work. Forget about the fruit. Look over the root. See, the growth of a plant is directly proportional to the growth of its root. If the root is not stronger, you cannot expect much product from the plant. Yes or no? Forget about the fruit coming from the tree. Look over the root. Make sure your roots are stronger than ever. Make sure you take these 6 to 7 months as a marathon to you. It's not a 100 meters, it's a long run. It's a marathon to you. You have to make sure you have to be there, and you are going to get a lot of obstacles, but you have to make sure to get over that and to stand behind that. When the tough gets going, or when the time gets tough, the tough gets going. Or when going gets tougher, the tough gets going. Make sure yourself the tougher than ever in your lifetime. And this is the time, make sure, and you open the gate through the gate. So this is what the strategy that I want to mention you. And along with my mistakes, this is my personal mistakes that I have done. So you can improve a lot while you are preparing. I may take a lot of time for you, but this is really important for you people. It's not about just listening in the classes. It's about you have to understand the importance of the examination. So that's the reason why every day, every time, see, it will take a lot of time for me to prepare a question. For one question, I'll take a minimum of 30 minutes, which means for giving you that assignments of 5 to 6 questions, I'll spend a minimum to 2 to 3 hours every day, apart from the class, for the sake of you have to understand. And for one question, I'm taking at least 25 to 30 minutes. Means for making you understand the questions in classroom practice also. I'm solving it. I'm solving ESC. I'm solving classroom practice questions. I'm giving you assignment problems with the solutions also. Make sure it counts, because the money that you paid is not yours. It was a hard-earned money from your parents. They have left their possessions, and especially your father. Your father might have some possessions, but he left all those possessions to save some money for you people. And 60,000, 70,000 is not a small amount for the middle class family, because hardly a middle class family can save 25 to 30,000 per month. And some of the families, like if you want to go for a movie, or if you want to go for a hotel for a month, they have to stop the expenses of hospitals. If they want to go for hospitals, they have to stop the expenses of the hotels and the movies. They have only one option. And majority of you are coming from the same type of families, and I was one of them at that point of time. And for my GATE study, my professor, my guide, my everything, my faculty, and because of him, he made me to feel as a teacher. He made me, he was the one to make sure myself, my goal as a teacher. And because of him, I was a teacher over here. And he paid me 30,000 for me for my GATE coaching in ACE Institute. I did not have enough amount of money. In my entire BTech, every day I used to make a tuitions, and I used to earn 2,000 to 3,000 rupees per month. And with that money only, I used to pay the hostel fees. And as I was a student of, I have a merit, so I got the whatever the fees reimbursement was there. So the remaining money I earned by having tuitions for 6th, 7th, 8th, 9th standard students. And those were the students of my faculty, my guide, my BTech guide. So under him only I have done my project also. So I used to teach his children of 6th to 7th, means on a second year, third year, and final years. I used to earn from him, and he was the one who paid me 30,000, not my family, because my family was not in a situation to pay for that. And because of him only, I got good GATE rank. I feel when I got a 600 rank, I feel like it was not good for me, because I prepared in such a hard way. I never left a small thing over there, and the small stones that I got unturned, that made me as a bigger, that made me regret for a long period of time. But whatever has happened is happened. But I'm telling you, everything you are having now, it's not yours. It's a worth of someone, their work, and they're paying for you for your better future. If you don't give respect to them, then you will not give respect to anything in your world. So respect to them, and respect to their worth, and respect to your parents, and respect to you, their money. It's their money, not yours. Work hard. Get into this zone. If you are not into this person, you will not have paid 60 or 70,000 to the ACE Institute. You want to enter into this path, and you will be in this path. And many of us, like me, a lot of faculties were there for geotech, for environment, every faculty, whatever the doubt you have, wherever you are, whatever the doubt you have, whatever the problem you have, whether it's a personal problem, whatever the help we can do, we can make sure yourself to be in a right path throughout this journey. So don't worry, there are some people on back of you to pat on you when you're doing something wrong. So make sure, attend to yourself, respect the time. And if you respect the time will respect you. If you don't respect the time now, and in the future, the time won't respect you. So that's all. With this, I want to conclude this one. Okay, so that's about. I asked your students, please send me a copy. I hope so. So, see, today I'm not going to take any doubt clearing session. Instead of that, I'll be taking this. Please. So I have taken a lot of time. We have to complete this chapter number 8. So we have some problems, and we'll see that problems. I hope it's not a motivation over here. I did not set any motivation. It's not about motivation. So I just make sure what is the reality. Motivation is something I don't want to say the balloon comes, balloon goes, something like that. It is your life and it is going to be wonderful. No, life is not going to be wonderful. It is going to be a full of means whatever the thorns. You have to walk over such type of thorns only. So don't think this is a motivation. This is just a reality. We always try to live in a small bubble of fantasy. Come out of that fantasy. Beyond your limits, there is a life. Beyond your comfort zone, there is a life. Come out of your comfort zone, make your life. That's it. So now I'll go with the questions. Please bear with me. And for this time, so let's solve some questions regarding to the age. Yes, I have been explained the question number 1 and 2. Now similarly, you please go through the you see this question number 9, please. See the question number 9, everybody. Question number 9. A cut is made in a stiff saturated clay that is underlined by a layer of sand. See, this is a clay. This is a clay, and here is a sand. What should be the height of water H in the cut so that the stability of a saturated clay is not lost? What should be the height of water on the clay so that the stability of the saturated clay is not going to be lost? You see, again, above clay, below is going to be sand. I told you clearly, this boiling condition can also see when a clay layer is underlain by sand layer, and this is nothing but Artesian condition or not? Yes. Whatever the upward pressure, see, first I'll go with the logic. Whatever the upward pressure should be equals to downward pressure. See, what is that upward pressure over here, please? So let's take gamma W as everyone. I'll go with the gamma W as 10. Observe the logic. I told you upward is equals to logic. Upward is equals to downward. What is upward over here? Gamma W, how much? 9.81. And this is Artesian head, how much? 4.5. So let's take this as a 10. I will take this value as 10. So I'll tell you later why. I'll take this value as 10. So 10 into 45, then upward is going to be 45, then downward should be 45. Yes or no? Yes. But what is this depth? This depth is going to be 2 meters. And what is the unit weight of the soil? What is the unit weight of soil? 19. So what is the downward given? The downward is going to be how much here? The downward is going to be 19 into 2, 38. Upward is going to be 45. Which is more, upward or downward? Upward. So then failure will occur. For that, what they have done is they kept some x value of water over here. So they're asking what is this x? Now you know the unit weight of water. Okay. So if you keep your palm over here along with 38, you can feel gamma W into x. This is downward now. Is equals to 45. Then gamma W as a 10. Then 10x is equals to 45. X is equals to 10x is equals to 7. X is equals to 0.7. The answer is going to be 0.7. If you use it as 9.81, then you see the answer is going to be 0.23. The answer is going to be 0.23. So what I am using over here is just simply the logic. What is the logic I mentioned you? What is the logic I mentioned over here? The logic is downward is equals to upward. What is upward? 45. What is downward? 38. In order to not to cause any failure, they have kept us this value. Then what is that value? 0.7. Let's go for this question. Question number 9. Classroom practice question. Classroom practice questions, question number 9. Now you see. This is the ground level, and here it is a clay. The total thickness of the clay is going to be 7 meters, and excavation is going to be 5 meters, and here it is going to be sand. This sand will exert an uplift pressure of gamma W into HA. So what is this HA over here? This HA is going to be 4.5 meters. Now there is a level of water kept over here. There is a water. So what is this? Here this is going to be water. Let's say this as some X, and you know this is going to be Z value. What is this Z value? 2 meters. So the total downward is equals to upward. I simply told you one point you need to know. For soil to be safe, you know that total downward is equals to total upward. So they have given some gamma sat, right? They have given the gamma sat over here. So now what is the total downward over here? Gamma sat into Z. You see, if you keep your palm, you know that, yes, in this zone, you know that what is the total downward. So you know that this is gamma W and this is going to be gamma sat. Gamma W into X plus gamma sat into Z plus gamma W into X is equals to gamma W into HA. So gamma sat into Z is equals to gamma W into HA minus X. Yes or no? HA minus X. So now you see, observe what is gamma sat given? 18 or 19. 19 into Z value as 2 is equals to 9.81 into HA 4.5 minus X. 19 into 2 by 9.81, 4.5 minus X. So which is going to be 0.626 or 0.63 meters. See, what is the problem with this? So if they don't mention artesian head, that is a pressure head. You see, artesian head means gamma W into HA. Pore water pressure means gamma W into HB. But anyways, you know that effective stress means effective stress is equal to total stress minus pore water pressure. If it is not going to be pore water pressure, I can write it as artesian pressure. I hope you understood now. Please go through this. So now let's see this question. After this question, now let's go for the next one. So these are the two questions that made. Now you see the question number 3. See this question number 3. You see this question number 3. If you observe the question number 3, yes. So now you see the question number 3. Water flows through a pervious material in upward direction. Water flows through a pervious material in upward direction means upward seepace. Assuming hydraulic gradient as unity, which means I is equals to 1. Estimate the seepace pressure in kilopascals. So they're asking the seepace pressure at a distance of 30% of the length of seepace from the entry point of flow. See, they're asking the seepace pressure at a distance of 30% of the length of seepace from the entry point. If net head causing flow, what is the meaning of net head causing flow? 5 meters, which means hydraulic head. So they're asking the seepace pressure. Now let's see. Let's see the question number 3. Question number 3. You see, this is a soil mass which is subjected to upward seepace with a net head causing flow, or hydraulic head is equals to 5 meters. So let's say the total length of soil is L. Let's say the total length of the soil is going to be L. So this is L, and given hydraulic gradient I is equals to unity as 1, and what is the seepace pressure at length is equals to 30% of the length. So you see, now everybody observe, I told you these type of things clearly. Now I'll explain you in a procedure and in figure also. At first your energy is how much? H is equals to 5 meters. As you travel, by the time you reach over here, what is your hydraulic head? 0 meters. Then what is the total head loss here? 5 meters. And what is the hydraulic gradient? 1. If the hydraulic gradient is going to be 1, then what is the total length? I is equals to H by L is equals to 1, which means L is equals to 1 into, H by I. So which is going to be 5 meters. The length is going to be 5 meters. But I want you to find out the seepace pressure at a distance. This is Lx from the starting point. What is Lx? Lx is going to be 0.3 times of L, which means 0.3 into 5, which is going to be how much? 1.5 meter. So now I want to find out the seepace head over here. Pehle your seepace head is going to be 5 meters. By the time you reach, you are traveling now, you lost some energy. Yes or no? How to find out the loss? Hx is equals to I into length up to x. What is I value? 1 into 1.5, which means you lost 1.5. Now the meaning over here is, in other words I can say, so first let me complete this one. Now other words I can say that, you see, by the time you travel from here to here over a distance of Lx, you lost 1.5. Initially your head is going to be 5 meters. Now seepace head at xx. Seepace head at xx. Hf of x is equals to total seepace head minus head loss up to this point. Total seepace head minus head loss up to this point. 5 minus 1.5, which is going to be 3.5 meter. Then seepace pressure is equals to seepage head data x, which is going to be 10 into 3.5. This is 35 kilopascals. Now, this is one way. Logic is, see, this is basic. Finding the hx, finding the seepage head data x. Now, this is basic. The logic is, by reaching, I can write, due to seepage, if 30% of head is lost, if 30% of head is lost, then remaining would be, remaining head would be 70% of total, which means seepage head at x is equals to 70% of total. How much? 5, which is going to be 3.5 meters. Then what is seepage pressure? Seepage pressure is equals to, at x is equals to 10 into 3.5. See, I'm just using the concept, interpolation concept. See, you see, starting point mein mera head 100%. Okay? Now, when you travel a length of Lx, you lost 30% of the energy. You lost 30% of the energy. When you lost 30% of the energy, you are going to remain with how much? 70% of the energy. Then what is the pressure head over here? Means not pressure head. Seepage head is going to be 0.7 into 5. Should I have to write over here? Where H is total hydraulic head, Hs of x is hydraulic or seepage head at x, and Hx is head loss at x. Now I'll show you one more way. Seepage pressure distribution. Everybody, what is mean by seepage pressure? Gamma W into H. So now, if you observe clearly, everyone have a look. Is it upward seepage or downward seepage? Upward. Starting point, your seepage head is 5 meters. Starting point, your seepage head is 5 meters. Then what is seepage pressure over here? The seepage pressure is going to be gamma W into 5, which is going to be 50 at starting point. Now, as you travel and travel, by the time you reach over here, everybody have a look. By the time you reach over here, what is the seepage head over here? 0. Then what is seepage pressure? Gamma W into H. So at this point, seepage head is 0. Then the seepage pressure is going to be 0. At this point, seepage head is 5. Then the seepage pressure is 50. Now, you know the head loss is going to be linear. I told you the head losses linearly. Then this is going to be the linear distribution. So now, what I want is, at this section, this is xx. What is the value? You know that the total length is going to be how much? The total length is going to be how much? 5 meters. The total length is going to be 5 meters. The total length is going to be 5 meters. You see, this is the total length. What is total length? 5 meters. And this is Lx. What is Lx? 1.5 meters. Then what about this remaining value? This remaining value is going to be 3.5 meters. 3.5 meters. See, I am representing this one as a logic over here. One more logic. I want to mention. Please have a look over here. There is one more logic. This is a pore water pressure, means seepage pressure distribution. This is seepage pressure distribution. Now, from the similar triangles, then for 5 meter, 50, then 3.5 meter, 35 kilopascal. Yes or no? Yes. Don't say no, because this is going to be 35 kilopascals. Because what is the total height? 5. Gamma W into 5, 50. And this is going to be 35, right? At this 35, this is going to be 3.5. From the similar triangles, we can write this is going to be 35. See, I explained you. This is a method 1. And this is method 2. And this is method 3. So 3 methods I have explained in this question. So you please go through this. I explained in all the ways of possibility. So okay, so now see, I explained you question number 1, question number 2, question number 3, and question number 9. So now I'm giving you this homework for you. Question number 4, 5, 6, 7, 8. See, 4 to 8. You please try to solve it today. Tomorrow I'll be giving that entire solutions. So, but today you please try to solve it. I thought of complete this one, but because as we have taken the session, so again today it has not been postponed. So, and I have one more session afternoon. I have other session, so I cannot continue today. So I'll stop here. And the doubt clearing session, I'm going to give it tomorrow, because you please go through that. These today's notes, you please go through that and you try to solve the problems. Tomorrow we'll solve. So today I'm giving you the questions, entire questions. So you please try to solve these questions, and tomorrow we'll solve the remaining. And today it will take a little bit time also, because I'm going to send the PDF. It will take some time for you people. So as I'm having a class now, I cannot be able to upload the PDF as soon as possible. So I'll be uploading the PDF by tonight, 8 or 9 o'clock. So if you have written notes, then you please go through that. But up to that point, so have a good day, and we'll discuss the class tomorrow. And today, no doubt session is there. Please go through the notes, yesterday's and today's. See, whatever the questions are here, the entire questions you try to solve. Whatever the questions are there in chapter number 8, whatever the questions are there, you try to solve it on your own. And tomorrow we'll see the solutions. And I'm ending the session. So with this.